What's going on, everybody? Johnny Bandon here. In today's video, we're going to finish up our Domain 3 section of our crash course for Security Plus SY0-701 exam. So we're going to go through Domain 3. At the end, there's going to be some questions, and you may notice I got a little bit of a different background here, going through a little life change, a little transition, but we'll be back in the studio soon. Let's go ahead and jump into it. Okay, so starting off our crash course, going over Domain 3. So we're going to start off by going over Domain 3.1.1. Compare and contrast security implications of different architecture models. This is going to be two parts. So we're going to have infrastructure concepts part 1. Let's go ahead and jump into it. So here's going to be all the infrastructure concepts we're going to go over. We can see the first section here, part 2 here. And then part 3, or really the last section of Domain 3, will be considerations. Okay, so the first thing we're going to talk about is something about cloud architecture. So I know we haven't dived deep into cloud architecture yet. Eventually, we'll get into what's called the service models and deployment models and different CSPs, the cloud service providers. But everything that is, well, there's a lot of things unique about cloud service providers, but a lot of things that stay the same is what we call our responsibility matrices. Now, obviously, between different providers like AWS, Azure, GCP, their responsibility matrices are not going to be one-for-one match of each other. But the general point of what we're trying to get here is, depending on what service model you're using, i.e. what you're renting, what you're paying the cloud provider to do, what architecture you're deploying in the cloud, how you're managing it, all depends on, really depends on what you need for your organization, but the responsibilities are going to vary between those service models. So kind of take a step back, right? If I am just using Google Drive, G Suite, to manage users' emails, storage for Google Drive. We call that software as a service. If I'm just managing an Office 365 where I'm assigning users' emails, giving them access to Office products, that's called software as a service. And in that kind of service model, just as a small example, all the backend, everything that makes Office 365 work, everything that makes G Suite work, the server, the code, the application, everything behind it, the data center where all the compute and storage resources sit to manage this service. All that responsibility is on the cloud provider. We call that software as a service. But in contrast, let's say you're deploying a server in the cloud. So you're bringing your own operating system. You're deploying your own code on that operating system. You're managing the middleware. We call that infrastructure as a service, where essentially you're just renting like compute and storage and network resource from the cloud, but you're still managing an entire virtual machine and creating a web server from it or a web application from it, and you're patching it and you're doing, IAM on it, identity access management on it. You're worried about the cybersecurity, you're worried about the attack surface. All that is your responsibility still. So in that service model, your responsibility, you take on a lot more responsibility compared to the cloud provider, where their responsibility still is just the general things the cloud provider does, which is have a data center, do the physical security for that data center, give you billing options, give you access to any of your resources via the internet, right? Kind of like the 5 tenets of what makes a cloud provider a cloud provider. Elasticity, access over the internet. I know I'm not naming all 5, but I'll probably put in here in the post editing the NIST documentation that lists that. That's still the cloud responsibility, but you have responsibility, all depending on the service model you use, okay? So it's important to understand the division of security responsibilities between the cloud provider and the client. And that's where you come in as the cybersecurity analyst. If you're in a change management meeting, you're in the architecture meeting, whatever that may be, and you're planning to move to the cloud, your role is to understand the threats that come about in the cloud and what your organization will have to protect and what your organization will have to take responsibility for, and what you can tell management, hey, that's on the cloud provider, or hey, that's on us, so we need to maintain, be responsible, patch, or whatever we need to do for whatever service we're deploying in the cloud. So that is the cloud architecture responsibility matrix. And again, between different cloud providers, these responsibility matrices may differ a little bit. Okay, hybrid considerations. So with our movement to the cloud, and this has been happening, right, the past 10 years, where major organizations are moving to the cloud, even small businesses move to the cloud, even if they don't know it, right? Office 365, G Suite, that's a cloud-based service. They may not, always categorize it as that, but as big enterprises are moving towards the cloud and also maintaining on-prem infrastructure, it's important that we understand security considerations there. With on-prem, we still have all the things that we need to worry about as far as physical security, identity access management, access to our data center, things like our capital expense we need to worry about, end of life, end of service, upgrades, quarterly patches, whatever the case may be, we still have to worry about that in on-prem. But then we also have to extend those same kind of security SOPs we have, that same governance, we have to extend it to the cloud. So there's considerations we need to take note of, or to at least inform our management of, when we're deciding to deploy a hybrid environment, especially if it can't be a seamless thing. Meaning if I have group policies applied on my on-prem Active Directory, can those GPOs easily transition if I'm doing AWS identity access management? Well, probably not, right? Just because the nature of it, you're gonna have to rebuild security policy in AWS. It doesn't sync like that. And then things like your incident response planning, your disaster recovery. Not only do you need to plan for your on-prem, now you need to plan just in case that cloud provider goes down. So maybe now you start thinking of multi-vendor, vendor diversity in the cloud. Just a lot of different things we have to consider when we move to the cloud. It's not as simple as a lot of these marketing schemes may be, but it is doable, and it is something that security has to be involved in. Third-party vendors. So by its nature, the cloud provider is a third-party vendor. So all that vendor risk management we would look for when it comes to our supply chain, working with VARs, all that same risk, that compliance still goes into working with the cloud provider. So we still have to do our due diligence into making sure that cloud provider meets our standards. Or maybe we're going with not one of the big three. We're not going with AWS, GCP, or Azure, or like a big one like Oracle, and we want to use a SaaS service, a SaaS application, excuse me. And maybe we work in the government, maybe we work in the DoD. Well, is that service, that application, FedRAMP compliant? So we had to do our due diligence. And then if we do deploy this third-party application hosted by another vendor in our environment, what kind of monitoring do we have on there? Are we integrating that into our checks, into our quarterly checks, into our patch management if we have to? Maybe we don't, depending on the service model. But we need to understand and define our security obligations and responsibilities with any third-party vendor, but especially the cloud, because we may host a lot of critical infrastructure in that cloud environment. Okay, infrastructure as code. So infrastructure as code is really what I like to think is a movement, right? Where we take a look at our infrastructure, whether that be the network, our different platforms, our applications, our servers, and looking at it as a single code base where we manage, update, and upgrade all from a single code, which gives us consistency, which gives us a source control management, which gives us code-based infrastructure that allows us to be more elastic, no matter what our infrastructure may be. So automating infrastructure and provisioning. IAC is the management of infrastructure in a descriptive model. Again, really all that word jargon is to say, I'm using Ansible, I'm using Python, I'm using Terraform to manage my cloud services. I may have, VMs in AWS. I may have some AI models working in GCP. I may have some serverless functions working in AWS. I may have identity access management in Azure. And I can use Terraform, a single code, to manage all three of those services, right? It's something repeatable, something consistent, something we put in a GitHub repo, something that we integrate into a CI/CD pipeline now, and that, enforces better change management in our organization. Now that's infrastructure as code. It's supposed to make things easier, it's supposed to automate, it's supposed to keep things consistent, get rid of some human error of traditional networking or traditional management where we SSH to an individual device, make changes, right? But of course, we have potential for security misconfigurations. Maybe our source code is hosted on a public repo. Ooh, nasty, right? Maybe we don't want that. Maybe that code is exposing something about our servers, our network infrastructure that we don't want to be exposed. So we have to worry about IAM to that source code. We have to worry about, how it looks in our environment. We host GitLab in our environment, but that's to the entire enterprise. But my department, we can isolate that. And that's something we have to worry about. Our GitHub, our Git project isolated, that no one in the entire enterprise has access but us because, our separation of duties. Code-based infrastructure also allows for version control. It gives you better history tracking and enhances your change management and traceability. Again, this kind of goes with like building pipelines to making changes in an automated, repeatable, and a codable way. But again, like down to the nitty gritty, this is just, hey, I'm going to use Ansible, Jinja templating, REST APIs, my IP address management source, and Ansible Tower to create an easy way to deploy VLANs to a network switch, or to deploy policy. I'll do the same thing, but now Terraform to deploy policy to all 3 cloud providers. That's infrastructure as code when you get down to the nitty gritty of it. Okay, serverless architecture. So what is serverless architecture? Now, I know what the name says, right? The name says that there's no servers. Well, obviously there's always going to be some sort of compute box with storage that is processing the code you're deploying or processing something. But in a serverless model, the cloud provider is responsible for managing the servers, scaling, patching, provisioning, and the availability of that server. Now, it's serverless to you because as the developer, and usually it's developer or DevOps engineer, a platform engineer deploying code, or deploying databases, to you, you don't worry about the underlying server anymore. You just deploy code to this. Sometimes this is called function as a service as well, okay? Now, you simply write and deploy your code without needing to worry about the underlying server infrastructure. That's all serverless architecture is. And this is given to us through our cloud providers. So some examples like AWS Lambda, Microsoft Azure Functions, Google Cloud Functions, something that we could get into a Google Cloud Console right now and go build and then deploy code to. So in that responsibility matrix, if you think about, working with the cloud provider, they're still responsible for the infrastructure. We're just responsible for our code, which does involve secure coding practices, IAM, API access, things like that are general security when deploying code. Like if you're building a web application, hosting it on a serverless architecture, like input validation, right? You still have those basic security things that are your responsibility. Okay, microservices. So microservices and service architecture sometimes get a little confusing, but they are different. Service architecture just kind of refers to the, I always think of it as just, you don't manage the server, right? You're just deploying code. Now with microservices, so microservice architecture, it is a design approach where large applications are broken down into smaller independent services. So think about our old monolithic web architectures. We had a database, a backend, and a front end. And that maybe all sat on one physical box or server. But now with the microservices architecture, we're splitting up all those different functions in that code, all those different methods in that code, and splitting them in their own smaller independent services, where each service or microservice is going to perform a specific function and communicate with other services using what we call APIs. So all these different microservices communicating via APIs to deliver a web application or to deliver an application. Now with microservices, there is some drawbacks. It is a better architecture, right, for deploying and scaling out things, but there's always an API. So with all these APIs communicating back and forth with each other, those can be exposed, so that can increase the attack surface. So if we don't secure those APIs, they can be victim to like injection attacks, broken authentication. So it's important we have that secure API communication, like adding TLS on it, doing that data in transit encryption. Okay, now on to some more physical network infrastructure. So we have something called physical isolation and air gap. So it's hard to sometimes like get into the nitty gritty of what's the difference between the two. But physical isolation, this is physically separating networks to prevent unauthorized access. With an air gap, this is completely isolating a network from the internet and other networks. This is in like highly secure environments. In the government, we do this a lot. With like our classified systems, they're air gapped. They only sit in their little siloed area of their classification in their own network. That's an air gap. In the regular, private sector, because I'm gonna post this online. Not everyone's gonna work in the government. This is like your CCTV system, where your cameras are all connected via Ethernet. There's Cat5, there's a switch, there's monitors that you can see your camera feed. But that's not tied into your enterprise at all. It's not even tied into the internet sometimes at all. We call that an air gap system. With physical isolation, this is just physically separating networks to prevent unauthorized access. It's just the physical realm, right? Where the air gap is kind of more logical, like, no. This network is not tied to anything. You see this a lot in ICS or SCADA systems, right? In those industrial frameworks. Okay, so more network infrastructure. So we have logical segmentation and SDN. So SDN, right? I have just a little notes about this, but this could be a whole week-long lecture on software-defined networking. But we're just looking at it from the perspective of the cybersecurity analyst. So logical segmentation. This is doing something like using VLANs. So in a traditional network, we use VLANs to logically segment at layer 2 by adding what we call VLAN tags. When we tag that tag traffic now belongs in its own broadcast domain with its own subnet. So that's the way we can do logical segmentation in traditional networking. Now, with software-defined networking, where we take that control plane, centralize it in a single pane of glass or a centralized server, and now we have southbound, northbound APIs, a single console where we manage hundreds or thousands of different network underlay hardware infrastructure. We can also do some separation there. But really what we're talking about when it comes to security is, where is SDN vulnerable? So SDN is vulnerable again because it uses APIs, so we can have insecure APIs when we're doing like northbound APIs, when we're sending REST API calls to our controller to go get information about our network. That's all REST-based APIs. We also have IAM considerations, so identity access considerations. If we have one logical pane of glass, meaning I'm logging into a web console and now I'm managing hundreds of switches, hundreds of access points, routers, right, with SD-WAN. If someone gains access to that, gains access to our vManage, right, that's Cisco SD-WAN, well, now you just expose your entire network. Yes, it does enhance network management. It enhances our ability to scale. It enhances the way we do upgrades. It gives us better accountability. It lets us have golden baselines a lot easier. It gives us consistency in our configuration. We don't have configuration drift, things like this. It's a way to automate. Talk about infrastructure as code. You implement software-defined networking. You have everything right there. So you have centralized security policy enforcement. But because of that, if it ever gets exposed, now you expose everything because all those control planes are in one centralized box. So it's just something to think about when we're deploying SDN from the cybersecurity analyst perspective, is now how do we secure this? Now, how do we secure this SDN architecture versus what we would have been doing with just a traditional architecture? Okay, let's go ahead and move on to the next slide. Okay, now let's move on. So now we're going to continue on with domain 3.1, going over our infrastructure concepts part 2. So we're going to talk about on-prem, actually break down what on-premise infrastructure is. So this is infrastructure and applications hosted within an organization's physical facilities, meaning that we go buy the servers, we have the data center, we're managing access to the data center, we're doing the environmentals on it, we're racking and stacking the servers, the storage, the network, and this is our on-premise architecture. So we have full control over the entire infrastructure, to include power too. I missed that out. So with on-prem, yes, you have more control. You have more direct control over everything. Cloud. So talking about cloud infrastructure now, we kind of already talked about it in the previous, but now we're just defining it. So this is just a cloud provider, right? It's a third-party vendor that delivers to you anything a cloud service provider provides. So services hosted by a third-party provider, accessible over the internet. So in here, we kind of go over the tenets of cloud architecture. They offer scalability, flexibility, and keyword, potentially lower costs. Because if you ever get exploited in the cloud and they start doing that egress network traffic from your VM, whew, you're going to have a hefty bill. But with cloud architecture, we have to have trust in that provider. We have to have a clear understanding of the shared responsibility model when it comes to security, which we discussed a lot in that first part. So more infrastructure, centralized for decentralized systems. So we talk about centralized versus decentralized systems. This could be about our authenticators, our identity providers, whether they're centralized or decentralized. But just to kind of break them down, in a centralized system, this is where decision making and processing are done by one central unit. Think of this like having Google Cloud, or excuse me, just Google as your centralized identity provider. That's a centralized system that's going to be doing all the authentication for users trying to access your third-party site. This is kind of getting into like OAuth 2.0 or OpenID, but that's a centralized system. Where decentralized systems, the decision making and processing is spread across multiple units or computing nodes or systems. A great example of a decentralized system that you may not even be aware of is the blockchain, which powers our cryptocurrencies. So this can be a little bit more resilient and fault tolerant because again, it's spread through, comes to the blockchain, I don't know, maybe millions of devices now. verifying the integrity of these hashes and encryption, which create our cryptocurrencies, right? So they can be a little bit more resilient and fault tolerant, but obviously it can be more complex to manage and secure because it's not just one centralized server, like with our centralized systems. Okay, virtualization. Now remember, this is just a subdomain of a 5 domain section security plus exam. So as much as I love to dive into virtualization, go over the different types of hypervisors, how to deploy an ESXi server or Proxmox, that's not what we need to worry about as far as the security plus exam. We should need high level defined virtualization in our next slide, containerization. So don't come at me in the comments saying you brushed over this. It's kind of meant to be brushed over, right? We're just, we're cramming for this exam. So what is it? Let's define it and then worry about some of the security involved with virtualization. So virtualization is creating a virtual version of something, including a virtual computer, hardware platform, storage devices, and computer network resources. When we think of virtualization just in general, when it comes to our enterprise, we think of deploying virtual machines to deploy apps and services. We think of taking a single bare metal server, putting a hypervisor engine on there, and then that server having the storage and the compute, us deploying multiple VMs within that server. So we get that scalability. But with that, we have security requirements now. So imagine one single server hosting 20 different virtual machines, 10 Windows operating systems, 5 Linux Debian-based systems, and 5 RHEL-based Linux systems. All those 20 systems, yes, they may sit on a single server managed by a single hypervisor, but now we have to integrate patching for that. We have to integrate OS hardening and updates for all those systems. So with virtualization, we scale, but we also scale our security. Then there's actual virtualization-based security vulnerabilities you have to worry about, like hypervisor or VM escape, where a user is maybe working in their VM, maybe like in a virtual desktop infrastructure environment, and they escape their VM and get into the underlying hypervisor. If they do that, they have access to everything now, right? So with virtualization, we also increase an attack surface. We have additional security vulnerabilities to worry about. And of course, like IAM to the hypervisor, right? We don't want anyone to get access to our hypervisor. Containerization. Kind of think of this as like the next evolution of virtualization, where containerization, instead of having a single VM per app or per service, which you have to manage the operating system and manage the middleware, the patching, the updates, the hardening, all this stuff. Well, containerization is the next evolution where we're operating on a single kernel, a host operating system with our container engine, and deploying what we call these container images to rapidly deploy applications and resources. So that container is just going to have all those dependencies to run that app, but we have none of that underlying operating system now we have to manage for each single app. You can kind of see it in this image here, where this is the lightweight OS level virtualization, this app right here that I'm able to access, but there is no underlying OS I have to manage and harden and patch. It's just the dependencies that are now being managed by this container engine, which is based on what's called the shared kernels, maybe like Linux, right? And this makes it a lot more resource efficient. Now, again, we're security engineers in this exam. What do we have to worry about? Well, when we deploy these containers, we typically pull them down from a online repo, like the Docker image repository. So that's maybe something that is secure when we download these containers. But if we get a container that maybe, I don't know, somehow got exploited in transit, or we're not getting it from a reputable source, then we could expose things like malware or anything malicious into our entire environment. So we want to make sure maybe we have some immutable containers and we're verifying integrity of these containers when we deploy them. Okay, IoT. So IoT is just Internet of Things. This is any of those devices that are not meant to be like dedicated, like, servers or services run. I don't even need to explain it that deep. This is your internet connected washer. This is your smart TV. This is anything that connects to the internet that is, increasing your attack surface with no built-in security mechanisms. That's how we look at it from the cybersecurity perspective. That if we have IoT devices, we know that that vendor, that manufacturer built that IoT device with the purpose of selling it, marketing it, and they probably didn't involve a lot of security, add encryption, full disk encryption or things like that. So when we're deploying IoT in our enterprise, we want to make sure we segment it. We want to make sure we harden it as best we can. getting rid of default credentials, putting it in its own VLAN. Okay, ICS or SCADA. So these are like those factories I talked about a little earlier in this video. So let's define these, these acronyms. What do they stand for? So ICS is Industrial Control Systems, and SCADA is Supervisory Control and Data Acquisition Systems. These are all used to control industrial processes. So we actually call this OT, Operational Technology, versus, IT, Information Technology, which is like the traditional enterprises you all watching this video maybe work on. Or maybe you do work in an ICS SCADA environment. What we really are worried about here is that our security mechanisms sometimes change here. We may have different compliance, different governance in our factories. We have a lot of legacy devices and technology in our factories or in our ICS or SCADA environments. So hardening but maintaining high availability is something that you always have to worry about in our OT environments. And really what this comes down to is just if you ever find yourself in an ICS or SCADA environment, you have to go with OT best practices, OT best security practices. Okay, an RTOS, a real-time operating system. This is designed to serve real-time application process data as it comes in, typically without buffer or delays. An embedded system. So these are computed systems with a dedicated function within a larger mechanical electrical system. You can see these little motherboard, little computing devices here. And the last thing we're going to talk about as far as an infrastructure concept is something called high availability. These are systems that are designed to remain operational for a very high percentage of time. And really when we break this down, right, at the keyboard levels that I like to call it, at the technician level, this is having backups. One is none, two is one. Sometimes we consider three as one, depending on how highly available we need to be and how redundant we need to be. We think about deploying this in the cloud. Maybe we're deploying a cloud service in the East region, and we want to deploy it and replicate it in the West region, so we have that high availability. Maybe we have hot standby pairs on our networking devices. So this is just the concept of saying, hey, make sure we're replicating, make sure we have some sort of backup on our critical servers or services or our straight up hardware infrastructure and even in our cloud environments. All right, awesome. Let's move on to the next slide deck and finish up domain 3.1. Okay, continuing on. Now we're going to finish up domain 3.1 by going over consideration. So in this exam objective, Security Plus calls this consideration. So we're going to go over considerations in our infrastructure. So resilience, really just defining terms that are going to guide us in how we build architecture in our infrastructure. So resilience. This is the ability of a system or network to withstand and recover quickly from difficulties or challenges. What we're saying here is that if it starts getting DDoS, does our load balancer react correctly? Or even if we just have an influx of users inbound on our web server cluster or our web application, can it be resilient? We plan for resiliency by doing failovers, by doing regular testing, like disaster recovery drills, having dynamic adaptation. So maybe systems that are designed to scale at the rate of bang, right? Hey, we have an increased load on this VMs in our cloud. So are we going to scale them out automatically, or does it require some sort of administrator intervention? Okay, cost. So in the cloud environment, we call this FinOps or FinOps, right? Financial operations. The financial consideration of implementing and maintaining security measures within a system. Now, again, this is Security Plus. We look at things from the realm of cybersecurity. In cybersecurity, we're not a profit generating force in, 8 out of 10 enterprises. Yes, maybe you work for a security company, so you say, no, I'm very important. I'm a cybersecurity vendor. And yes, you're right. You are the profit, generating force. Really, your salesmen are. But anyways, the cost, right? So sometimes it's important, especially when we get up to our management where we want to implement something, what is the cost? And do we have to do a cost to benefit analysis? What are we gaining as an organization if we front this cost for this new security or IT system? And do we have a long-term plan for it? So if we're going to implement something, what's the shelf date? What's the EOL? What's the EOS? Does this integrate well into our systems? Which is kind of getting away from the cost, right? But pretty much, is there licensing with it? What's the total cost? What's the capital expense? What's the operational expense of implementing this cybersecurity system? Okay, then responsiveness. So this is the ability of a system to respond and adapt quickly to changes, including potential security threats. I like to think of this as us deploying, our defense in depth approach, our onion layer of security. And do we have something like EDR, XDR in our systems that have playbooks that can run automatically when they detect malware, right? That's our responsiveness. So how agile are security protocols? Do we have a SIEM or SIM device, an SIEM device doing user behavior analytics? And when we see something that deviates, do we have SOAR integrated to automatically remediate that, deviation from the behavior baseline? How do we alert properly? Do we have automated systems to alert us of a SEV1 or a SEV2? How are we getting alerted? Even our processes of organization, who's the on-call admin and are we able to get a hold of them? So that's our responsiveness just as an organization and in particular systems. Scalability. So the capacity of a system, we really have two types of scalability. I don't know if they're defined in this section, but vertical and horizontal scalability. Where vertical scalability is a single node that we increase. So a single node that maybe, we thin provision, where pretty much that is like, hey, we're only gonna use 100 gigs of storage, 4 cores, 8 gigs of RAM, right? But it has the capacity to do more. On that motherboard, we have a lot more storage. We have a lot more compute power, a lot more cores, a lot more CPU, a lot more RAM, but we don't need it. And then as our load increases, do we scale it up? And how do we scale it up? Is it automatic or or do we have to have downtime to scale it up? So that goes into our scalability consideration. Then we have something called horizontal scalability. That's where we pool multiple nodes together, create some sort of cluster to, you know, to serve whatever application that is. So horizontal scalability is pooling multiple nodes together. Think of this as like, a Kubernetes cluster scaling out containers in a response to an increased load. Easy deployment. So sometimes how easy is it to roll out a change? How easy is it to roll out patches? In certain organizations, this matters a lot. Maybe we're managing like these banks in Alaska that are cut off from high-speed internet, and we have Linux servers on-prem there. Maybe we have to deploy Red Hat satellite servers that say, hey, this server is going to pull down an entire repo and then service all those servers because they don't have enough bandwidth there, right? So easy deployment. It's like, how simple do I need to make this? And is it easy for whoever's there, for our IT admins, or even based off the geolocation? Do we have to think about governance and compliance when it comes to our ease of deployment, right? So can we streamline? Can we automate? I have this Starlink terminal there. So is that an easy way for us to get WAN access to our austere locations rather than working with the local, ISP there? Risk transference. So kind of getting more into specific cybersecurity terminology here. So this is the practice of transferring the risk of a potential loss to another party. This is like cybersecurity insurance, where maybe we know a breach is possible. We have the potential for a breach in a system. And instead of trying to mitigate it or accepting it or avoiding it, we do risk transference, where we say, hey, we're going to get a cybersecurity insurance policy. And if there's a breach, they're going to, take the hit for us. So outsource the security functions as well. Outsource certain security functions to specialized third parties, but ensure that the responsibility and expectations are clearly defined. So maybe we're going with an MSSP, a managed security service provider there. Okay, easy recovery. This is the ability of a system or organization to recover quickly from security incident or data loss. Now, this is factoring in our RTO or RPO times, our mean time to recoveries, our mean time between failures. And if a system goes down, do we have the right personnel on there to get it back up? And how do we plan for this? Well, we plan for this by actually simulating or emulating disasters. We say, hey, do you know what to do if this gets breached? Do you know how to properly quarantine, how to properly eradicate and bring a system back online while also maintaining the chain of custody, right? Do you know how to do forensics properly? What are you going to do if a system actually fails? We have major power outage, right? Do you know how to deploy to coop over, do the continuity of operations to our hot site as the primary domain control, whatever the case may be? What is the ease of recovery? And do we know it? Like as an organization, are we aware of how easy it is to recover our systems? Patch availability. So this is the availability management of software updates designed to cover security vulnerabilities. Do we have a patching system in place? Are we doing like Microsoft SCCM where we're deploying patches and software updates? Do we have a centralized repository for our Linux devices that maybe we don't want to reach out to online? What's our patch management policies? When we get a patch, do we apply it right away without any testing or sandboxing in our environment to make sure it doesn't mess anything up, this new patch? And are we doing proper assessments? Are we even aware of what needs to get patched? Are we doing the proper scans in our environment to be aware of our patches? Inability to patch. So this is, hey, we may have a system that we can't patch. It's legacy. It's end of life, it's end of service, and we can't update. So if we have an inability to patch, what do we do then? How do we compensate? Well, one, we have to harden the device. Maybe we isolate the device. Maybe we do proper risk assessments and let management know if you're saying we can't update this because you don't want any downtime on this critical service, here's your risk assessment. And I need you to accept this risk as our management, right? As a person's or people taking responsibility. And if we do eventually want to upgrade, do we have to have a nice detailed migration plan that is tested in a sandbox environment that we make sure we have proper rollbacks? Because maybe this is a critical service and that's why the business says, hey, this is a profit generating service that we don't want to go down. Figure out another way to make this secure. And that's sometimes how it goes. And we say as a cybersecurity team, okay, let's do some, let's do some hardening, intrusion detection. Let's firewall it up. Let's isolate it and let's try our best, right? Okay, power and compute requirements. So this is a consideration, right? When it comes to power, it's something that as cybersecurity professionals, we don't always think of. It's something that kind of just maybe slips our mind to say, why are we worried about that? But it's important because as cybersecurity experts, we in the CIA triad, what's that A? It's availability. So we have to make sure that our power is redundant. Do we have generators with automatic transfer switches? Do we have ups for everything? Ups that can actually take on the capacity of our data center racks. If we have rolling brownouts, are our ups accounting for that? Do we have multiple power lines coming in, just like an ISP connection? Maybe we go with multiple power lines that are not, that are geographically diverse, meaning if one goes down, maybe the other can stay up. So we have that physical diversity in our power lines. Then, of course, compute requirements. If we're going to buy a deep learning server to manage our own AI locally, do we have the right server with a lot of GPU? Maybe we're doing a lot of encoding or transcoding. Maybe we need a lot of GPU. What is our specific compute requirements for our enterprise and our purposes? Okay, awesome. So that is going to be it for domain 3.1. Let's move on now to domain 3.2. Okay, now let's start going over domain 3.2. This is given a scenario, apply security principles to secure enterprise infrastructure. And we're going to go over infrastructure considerations. So let's just take a look at our objectives here. When we talk about infrastructure considerations, this is going to be how we set up an entire infrastructure, meaning look at this from a holistic point of view. Where are we placing our access points? Wireless access points. Where are we placing our physical access points? Do we have security zones? What is our overall attack surface? How do we build the defense in depth to reduce that attack surface? We'll go over things like fail open or fail close. We'll go over active versus passive, inline versus tap monitoring or scanning. Then network appliances in the next video, and this will be our last video in 3.2. These objectives. Okay, so infrastructure considerations. So this involved the strategic planning and setup of an organization's network architecture to ensure robust security and efficiency. So in the context of cybersecurity, our infrastructure considerations are in our architecture, our entire domain, our entire enterprise. How do we ensure that our systems are secure? How are we following that CIA triad? How are we building that defense in depth approach while also keeping systems highly available and ready for use? So a couple key notes here on the slide. System compatibility. Do things in our infrastructure talk, and do they talk well? Meaning, are we just a single vendor? Do we have Linux devices that we want to integrate into Active Directory to apply group policy? Ubuntu can do that now, just off the top of my head, right? Can our infrastructure communicate well? And if it does communicate well, how are we monitoring it? How are we scanning it? Is it scalable? So are we planning for future growth? So scalability, we talk about a lot in terms of like the cloud, but this has always been a thing in IT infrastructure. When I used to set up infrastructure in the military, we would say, hey, we need a /27 subnet, but actually we may need a /26. We may get an influx of users 2 weeks from now. That's something just so small scale, right? Just the size of your subnet But scalability is important in an organization. Are we planning for future growth? And if we are, how are we integrating that in? Meaning we don't want to cap ourselves and then have to go all the way back to a drawing board saying, hey, sorry, we didn't buy the right server at the time to give us correct vertical scalability. And now we need to spend a lot more on our research on the actual capital expense. And then how resilient are we to threats? So are our systems redundant? If something goes down, how quick do we come back up? Do we have some high availability in our network or our system infrastructure? If malware does get, or a system does get exploited, get infected with malware, how do we as a SOC team, a Security Operations Center team, how do we react? And if we don't need to react, what systems do we need to put in place? So what I mean by that is, do we have good remediation systems that are automatic? Okay, so the first thing we're gonna go over is device placement. So strategically placing network devices, we like to give an example of this as wireless, right? It's a big one. You're doing a wireless survey, you have a wireless network you're gonna support. Do we have coverage? Do we have coverage on all the floors? Where do we have a lack of coverage? But this also comes into security. Maybe there's some physical security we have to be aware of with device placement. If we have a comms closet, do we need to put an extra two-factor thing on there, like a card reader plus a fingerprint scan to get access to that comms closet? Optimal performance. So are we putting devices in the right place for our performance? And then fault tolerance, of course, right? If one device fails or is compromised, how tolerant is it? So do we position devices to provide continued service? Now, device placement, again, this kind of works in the physical realm, and that's why I put up here wireless. But in terms of security, that's also something we have to think about. Like, if we don't want to fall victim to wireless attacks. So maybe something like an evil twin. So maybe we say as part of our onboarding, hey, we place these wireless access points that you can only get access inside the building. So if you can access our wireless network in the parking lot, in the back row, that's an evil twin, and that's not something you can connect to. Now, again, very niche example, but that's just something in the security mindset here when we talk about device placement. And then, of course, physical security. Do we have the right barriers? Do we have what's called man traps or access control vestibules to get access to our campus and to our offices? And then, okay, security zones, right? So it's kind of going over that. Security zones are segments within a network where specific security policies and access controls are applied to regulate traffic and resource access. This can be physical and logical. I put in a picture there of what I just described, a man trap, but when it comes to logical, this is segmentation. This is network segmentation at multiple different levels. This could be at the network. So in a traditional network, we have VLANs that segment. This could be on a policy base. We could have group policies that are associated to an organizational unit, that are associated to a subnet, and that subnet correlates to our accounting VLAN. That's a security zone. This could be in how we deploy applications. We can have a staging environment, a development environment where we make changes and things can be broken and they can be vulnerable. But then before they go into production, we put them into our staging zone, right? This could be logical segmentation in the cloud with different VPCs, virtual private clouds. In Azure, we call these VNets. We build VNets that have subnets that we can also attach network security groups or application security groups to, or zone them based on firewalls. So we have a traditional network. We have a hardware firewall. We have a Palo Alto. They zone things out. We could have a security zone that's untrusted, a security zone that's trusted, and then a DMZ, a demilitarized zone, which faces the internet and faces our internal network. We can have controlled access points like what we show here, where it's in the physical realm again. Okay, and then attack surface. So what is the attack surface? We kind of went over this in domain one, but the attack surface is just our entire architecture, how exposed it is, right? And when we say exposed, doesn't mean like we're immediately vulnerable, but where are our attack vectors? If we have a VPN concentrator, if we have public web servers on-prem, in the cloud, do we use credentials that aren't multi-factored? Do we have an employee portal that can be accessed? I access my employee portal from the internet, right? Where I go put in my time card and things like that. That's our entire attack surface combined into one. So where are we vulnerable to attacks? And are we vulnerable to attacks? Or where is the attack vector that can be targeted? Now, once we understand what this is and we get that sum total, so we run our scans, we do penetration tests, we do our due diligence to say we're maybe vulnerable at A, B, and C, at our public website, our employee portal, our Office 365, we don't have proper IAM, we don't have conditional access on our Azure B2B users or B2C users, right? Whatever the case may be, we have to recognize that. And then once we recognize it, employ security controls, policies to reduce that attack surface. One of the easiest ways to reduce attack surface is by hardening devices, by implementing good identity access management. That's just some of the simple things. And then as far as the attack surface goes, how do we know if it's gotten better, if it's gotten worse, if we've reduced the attack surface? With continuous monitoring. So having our monitoring systems, whether that's a Nessus scan, whether that's a SIM or a SIM, doing continuous monitoring, an IDS or IPS system. Okay, connectivity. This is just gonna be a simple one where I don't want to spend too much time on this because I feel like I'm being a little long-winded. This is just how connected are we, how stable of our connections. That could be from internal to internal resources, internal to external, external to internal resources. How connected are we? Do we have the right speeds, the right bandwidth, the right VPN connections for our remote workforce? How reliable is our network? That is what we mean when we say the term connectivity for the Security Plus exam. Okay, failure modes. So failure modes, these are the various ways in which a system component can fail. So we're gonna go over fail open and fail closed. So fail open. In a fail open scenario, this refers to a security system defaulting to allowing access or continuing operations when it fails or malfunctions. So what we mean by that is, let's say, I don't really have a good example in real world, but let's say on our whitelist, right? Or let's say a blacklist. We say, hey, we're gonna deny all these applications, and then there's an implicit permit at the end. To me, that's kind of like a fail open, and you can roast me in the comments if you think that doesn't a good way to describe it. But what essentially that means to me is, hey, I went and denied all these bad domains, everything that I thought was a bad domain, and now a user somehow found a different domain with that same malware and got it installed on our network. I call that a fail open because my blacklist didn't work. And since it didn't work, it allowed something in, right? It got past all those deny statements and got to that implicit permit. That's what I look at as a fail open. Now, just to go through the slide, right, to read it off to you, this ensures that critical operations and access are maintained even if the security system fails. So potential security risks while maintaining operations, it might expose the system to vulnerabilities during the failure period. Okay, then fail close. So in a fail close scenario, the security system shuts down the operation or access it controls in case of failure or malfunction. Now again, I always look at this like a whitelist, which is different. That has an implicit deny at the end. So I need to go and permit things that are allowed on the network. And then if a user does go to that bad domain, because I'm thinking URL filtering here, not just application downloads, it won't let us, right? It's saying, can't go there. You just hit our implicit deny at the end. So in a fail close scenario, the security system shuts down. Yep, already got that. It enhanced security posture, so it prevents potential unauthorized access or breaches during system failures. But it does lead to service interruption, right? Okay, device attribute. So in the context Security Plus, these attributes that we assign to devices. So we can have a group policy that's built for our whole accounting OU. So we can have an organizational unit and an Active Directory force that says all the accounting department is in here. But then within that OU, we can have it sectioned off to laptops, server, computers, and, well, maybe not mobile device, but printer. Let's go with printer, right? And then within that accounting OU, we can put a little attribute on that object we put in there that says, hey, this is a printer. So because it's part of the printer, we're gonna add this additional attribute to it that it needs additional access to something in our network. So we can apply those device attributes to kind of be more granular in how we control things. It helps us do better device identification and can help us be a lot more specific in our configuration management. So let's read off this definition here. Device attributes are the inherent properties or characteristics of a network device that define its role, capabilities, and behavior within a network. And again, like a good example, right, what I just described when it comes to like group policy for these certain devices. Attributes are crucial for applying appropriate security policies and access controls based on the device's role and capabilities. So active versus passive. So when we talk about active versus passive, I like to think of this in terms of scanning. Now, Security Plus in this exact domain is just kind of being holistic again in its approach to describing active versus passive when it just comes to your architecture in general. But let's get into it, right? So active devices. These are going to actively manage, control, or block network traffic based on predefined security rules and policies. So that's active, right? So think about an active scan. So an active scan is when a device, like let's say an ACAS scanner, like Tenable, or even a SIM system or a Nessus scan, goes and actually touches the device. It's going to touch the device. Not only is it going to touch the device, it may install some sort of agent on there, and it's going to actively decide what that device does or does not do, and it's going to actively take that traffic. right? It's not just looking at old logs to look at traffic. It's going to look at what's going on that NIC to this device that I'm scanning. What's happening right now in real time. That's an active scan, right? Where it's not, looking at logs and saying, oh, historically this has happened or this happened a day ago, look into it, right? And with active devices, we're going to have predefined things for it. We're going to have predefined security rules and policies. That could also be something like a SOAR system, a security orchestration automation remediation system, right? That's an active device that can go and actively block traffic and scan and monitor. Now, passive devices, these are just going to monitor and analyze traffic, generating alerts or logs. So it's not going to directly interfere with the traffic flow. So this is where it gets a little confusing. So a passive device can still touch a system. It can still touch it, it can still gather information, but it doesn't do anything. It may not gather even real-time traffic. It may just, again, ingest logs, look at historic traffic. It could monitor and analyze traffic, but it's not going to do anything. It may just alert. It may just tell you about something. Now, when would you want to use one or the other? So if I have an active device and my goal for an active device is to stop traffic if you see something malicious coming up, and in my organization, we don't care about cybersecurity. Let's say the C-suite says, yeah, we care about security to keep up. We just don't want to be completely worthless when it comes to cyber. But that e-commerce server, that stays up. That's how we make our money. This factory, this thing, this appliance, that's how we look at it. This thing that generates us money, it stays up no matter what. Maybe I don't want to do an active approach to that device, even if I do notice malware, because that goes against what our company policy is, that it stays up no matter what, right? We generate profit no matter what. There are organizations like that do not put cybersecurity first. And throughout your career, you'll see that sometimes. So passive devices, that would be a better deployment in that scenario where we say, hey, this IDS system is just going to detect, it's going to alert, it'll tell our cybersecurity analyst, and we can put different severity levels on it. We can say it's a SEV1, but we're still not going to block traffic. And then that SOC analyst that receives that SEV1 report goes to his manager, and then it goes to the correct stakeholders, and then they decide, yes, stop that traffic. We don't want a data breach that gets on the frontline pages of Bloomberg or CNN, right? So there's a balanced deployment in these two. Inline versus tap/monitor. So inline, this directly influences network traffic. I like to think of this as like NetFlow, right? Something that sits in line. I think this is an IPS system that says, I'm gonna sit at my Ubiquiti 0-1 firewall and router, and if I notice something leaving my egress, my demarcation point, my WAN interface to the internet, I will block it. I am in line. I'm right there. You cannot pass me. You can't get the internet without passing me. That's an inline device, okay? A tap or monitor device, that sits not in the direct path of network traffic when it goes to its destination. I think this is like Splunk or a SIEM system, Security Information Event Management System, that sits on a VM, on an ESXi cluster, that sits in the cloud somewhere, that doesn't sit in line, but it still monitors. It still taps into the network and says, let me see what's going on here. This is like span, right? If you set up span on a switch, it's going to, yes, it's kind of in line with the traffic, but what you're actively gathering, the packet captures go to your computer that has nothing to do with the flow, right? The span, you get a switch, you put a span port on gig 1 and gig 2, so you're duplicating all the traffic coming from gig 01 and sending it over to gig 02 where your computer is and you have Wireshark pulled up. Well, gig 01, that computer still can talk to the internet. You're not going to be able to prevent traffic, right? Just because you configured span on that port. That's another tap/monitor. Okay, awesome. So that is domain 3.2.1. Let's move on to our next section in domain 3. Okay, moving on. So now we're going to continue on with domain 3.2, and now we're going to go over network appliances. So let's take a look at our objectives here. We're going to go over the different physical appliances, the different software appliances that could live in our network, go over some security, and then go over the different firewall types. So network appliances, these are just devices that live in your network that have a specialized purpose. So a jump server, let's go over what a jump server, sometimes you call this a jump box. So this is a secure and controlled entry point into a network segment. I love this drawing we made up down here because this explains a jump box perfectly. We have our data center, which would be like our IT, our enterprise, maybe our domain controller sit here, print servers, web server, whatever is in that data center, storage, right, for our enterprise. Then we have our ICS, which is our industrial control systems. That's OT, that's operational technology, that's our factory equipment, our sensors. And they're segmented. Whether they're physically air gapped, which they're not because they are touching at one point, you see that firewall they're connected to. but we don't want to be able to jump between those two. We don't want them in some sort of hub and spoke topology, some sort of two-way path. We want them completely segmented. So we want to remote manage them. So how do we do that? You can see here we have two management computers, one that sits outside the entire domain or architecture, one that sits maybe internal. And we have a jump box that sits between two firewalls, probably a zoned right here. And that jump box will be the only place that we can SSH or RDP or any remote management into these different network segments. So everything has to be done from the jump box. So we can't just go straight from this device into our data center, and we can't just go straight from this device into our OT environments. What we'll have to do is come to our jump box first. So that's not our jump box. So let me erase that. We have to go to our jump box first. So we'll have to SSH here. This could be like a Linux server. This could be a Windows server that allows maybe RDP. Not recommended if that's over the internet, but maybe TeamViewer, whatever the case may be. So you have to come here first, and then from there, that source IP will be allowed into our data center or our ICS systems. Now, a lot of times what people do, what I guess I've seen in big enterprises, if they'll have the jump box, and that jump box may also be an admin box. And what we mean by that is the computer that you're taking home is not going to have all the applications you need to manage like a Cisco UCS chassis. You're not going to have the MMC installed to access Active Directory on your computer. It can all be done from that admin box there. I've seen that done before when you're in a large enterprise of multiple admins. It's kind of like privileged access management a little bit. Okay, awesome. Proxy server. So a proxy server is going to act as an intermediary between end users and the internet. Proxy servers are very common. Sometimes we don't even call them proxies anymore, but that's what they're doing, right? When we have a web server that sits internal, technically that router that's PAT enabled, port address translation enabled, it's kind of like a proxy, right? In the cloud, we have proxy servers as well. We have load balancers or NAT gateways that will also act as a proxy to our web applications that sit in the cloud to the external, to the internet. But let's just go over the actual definitions. So a proxy server acts as an intermediary between end users and the internet, providing security, administration control, and caching services. So again, it can do things besides just being that proxy. So really the way this works, guys, right? It gives you privacy and anonymity and masks the IP address of users, providing privacy and a level of anonymity. But like in this reverse proxy, you see this IP address here. Oop, that's a little big. Let me get this pen out. This 12.3.3.2. Essentially, this will probably be our A record, which means that'll be in the global DNS, whatever this web server is over here. So if this is trepatech.com and I have a web server farm, my global IP address will be 12.3.3.2. So when users from anywhere go to accesstrepatech.com, they're hitting this outside IP address here. And then we have this virtual IP or this inside IP address that all these servers talk to here, right? And essentially this is going to be a port address or a NAT, a network address translated enabled device that says, hey, when this user is trying to access 12.3.3.2 on port 443, they're trying to reach these web servers behind there. So I'm going to translate that. I'm going to send it out via 10.1.1.1. They're going to respond to 10.1.1.1, and then I'm going to send it back out to whatever user that is and change my source back to 12.3.3.2. So as the user back here, I never know the true IP addresses of these web servers. Now again, they're private IPs, so it wouldn't really matter. But even if these were 3 different public IPs, these were all 1.1.1.2.3.4, the user would still see that web server as 12.3.3.2. We'd never know the actual server sitting behind here's IP address. We never directly connect to it. And then with that proxy, we can do a lot of other things to it. Now, this would be more on a forward proxy, but we can do like content filtering. I've seen this in the enterprises I've worked in a lot, where before we hit the internet, when we're doing like an HTTP request or HTTPS request. So it should be set up, well, I'm not gonna say should, but I've seen it set up where an end users, like this forward proxy will sit in line, so we'll see all traffic. But when it notices an HTTP request or an HTTPS request, it's gonna say, okay, I need to filter this, I need to inspect it. So we'll probably have like TLS, inspection on here. And what we're gonna do is we're gonna filter the content before we translate it to this public IP, okay? Or it could translate to a different private IP and then the router's not enabled. But the big difference between forward and reverse proxy is the forward sits on the user end, the reverse proxy sits near the web server, okay? And we also have some other additional things a proxy server can do, like caching, which stores local copies of frequently accessed resources to improve response times. That's something, again, you might see a little bit more on the forward proxy, where users constantly go to, a blog, a popular blog site, like a Medium post, right? For a user that, I don't know, their favorite Red Hat Linux Medium blog poster, right? So we cache that on our forward proxy. So now the users just have maybe talk straight here instead of reaching out to the internet to hit a website or a web server. Okay, intrusion prevention and intrusion detection systems. We've talked about these a lot, so I'm not going to spend too much time, but there's network-based ones, right? We have hosts, we have network-based intrusion detection and prevention systems, and we've talked about these in the other sections, so we'll be quick here. But an IPS does an active security scan, which pretty much says, hey, we're going to be able to detect and also prevent traffic. Then IDS will be more passive, where it just monitors and alerts, but it doesn't actually prevent anything. The way that we set these IPS IDS systems up when we're doing these scans, what is it scanning for? We can have signature based, where it's just a file of historical things that are malicious, right? History of all the malware or all these CVEs. Or we can do something like anomaly based. We have our IDS or IPS systems do user behavior analysis. So they analyze user behavior on the network, and they say, hey, normal operations run 9 to 5 using this much bandwidth. These sites are always accessed. And if all of a sudden at 2 a.m., my IPS system, my intrusion prevention system, sees a lot of data leaving, going to a remote site that we're not familiar with, that's beyond our normal user behavior baseline, we're going to prevent that. Or an IDS system will do the same thing, but instead of preventing, it just logs. It may send an alert. It may send a SY0-701 alert, a report to the on-call technician, right? So you're getting a call at 2 in the morning. All right, sorry, moving on. Some tech humor, right? If you're ever on call, it can be a little rough. Okay, a load balancer. So a load balancer, just exactly what it does, high level. It efficiently distributes incoming network traffic across to the destination, across multiple servers, and this is going to optimize resource use, throughput, and response time. We could deep dive into load balancers, how we deploy them in the cloud, how we deploy them on-prem, how we decide to distribute traffic. But the main goal of a load balancer, what you need to know, is that it makes things highly available, it makes things on the network highly available, it distributes traffic, and it provides redundancy, okay? There's so many different algorithms we can use to load balance, but that's the main point. And it also lets you scale. It lets you scale out your incoming network load. It helps prevent against like DDoS attacks, things like that, by, again, allowing that high availability. Okay, port security. So port security as a technology that we configure on a switch. All this is a layer 2 mechanism to control traffic or to restrict layer 2 traffic coming in on that switch. What it essentially does, it says, hey, if I enable port security on that switch port, remember, switches learn via layer 2, via MAC addresses. So when we have a layer 2 frame inbound on the switch will take a look at that source MAC address, or that ingress MAC address, and apply it to the MAC address table, or write it to the MAC address table that says, this MAC address lives off this interface, gig 005. Well, there's no limit to how many MAC addresses can be learned on that port when we just have a regular access port for users. Port security does. With port security, we can say we're only going to allow you to have one MAC address on that port, meaning that if I plug in a Kali Raspberry Pi and I want to do a frame flooding attack, that port will shut down the moment it gets more than one MAC address. Or we can do maximum of 2, whatever the case may be. That's port security, filtering based off MAC address. We can also say, hey, switch port, we only want you to have this MAC address. So we can assign a specific MAC address to that port, and all the MAC addresses won't be allowed. We can say sticky too, saying, hey, whatever plugs into you, even on reboot, because when a switch reboots, it clears that MAC address cache, it's RAM, it's volatile memory. Even on reboot, that MAC address is going to still be the one allowed on there. The one we remember that should be on this port, okay? So it's a dynamic way to control MAC addresses on the switch. But it's very simple, right? It's just MAC address filtering at the end of the day, or limiting the amount of MAC addresses that can be on there, or allowing a certain MAC address on there. That's what port security is on our switches. Now, 802.1x. This is going to be a little bit more complex of a network protocol that does the same thing though. What it does is it restricts who has network access? Who has access to our network at the switching level? Meaning I plug in an access point, I plug in a computer, 802.1x is gonna do its thing. It's gonna maybe integrate into something like Radius to talk to a AAA server that's going to say, can this device be allowed? Do you have a profile for this device on the network? And if you do, then I'll allow it network access. I'll let it get an IP address from our DHCP server. So this is still port-based network access control. It grants network access only after successful authentication of the device. So before, when I plug in a computer on 802.1x enabled switch, there's a lot of things in the background I got to do. A AAA server, configuring 802.1x properly on the switch, putting in a computer's profile or tying it into Active Directory group policy. However I skin that cat, right? When I plug in a device into a switch, before it gets access to that VLAN, it gets an IP address, and it can start roaming on our network. It's going to go through the 802.1x authentication process, okay? And it's going to be from a centralized authentication server like a Cisco Identity Service Engine, whatever AAA server, right? And once that centralized authentication server grants access, then guess what? We can now be on the network. That is what 802.1x is. I'm not going to get into the deep complexities of it, with the supplier, the supplicant, the authenticator, the different components of 802.1x, because at a high level, just know 802.1x enables us to have NAC, or Network Access Control. That's what you need to know for the Security Plus exam. Okay, EAP, another component when it comes to authenticating devices onto our network. This is actually a framework, right? It's a component, but it's a framework that supports multiple authentication methods. So the actual transmission of credentials from a user to the authentication server can be built in EAP. In that extensible authentication protocol, we can add things in there like TLS to secure and do that data in transit encryption for that authentication service, right? So EAP is a framework that allows us to add additional security mechanisms on top of that authentication, okay? That's what you need to know for the exam, that it's a framework, okay? EAP is a framework that supports multiple authentication methods. Okay, now firewalls. So let's get into different firewall types. So firewalls, whether they're in a traditional sense, a hardware appliance, or they're in your cloud base, it's a virtualized firewall, they all have one function: to filter traffic. To filter traffic, that is what a firewall does, inbound and outbound. That's it. Now, how it gets there, there's a lot of different ways, right? So we have packet filtering firewalls. These are firewalls that examine each packet independently and permit and deny based on user-defined rules. Now, we say user-defined rules, we mean like an admin went in there and said permit and deny all these different types of traffic. We have stateful inspection firewalls. That's going to track the state of active connections and make decisions based on the context of the traffic, not just the individual packets. We have application level firewalls, or what we call proxy firewalls sometimes, or next generation firewalls. These are actually going to filter based on applications. So these will do our deep packet inspection and say, hey, what website are you going to? I'm going to filter based off that URL. I'm going to do that deep packet inspection. Whereas packet filtering versus stateful inspection firewalls may be configured just to filter based off the port or protocol. So layer 3 or layer 4, destination IP address or destination protocol. Okay, a web application firewall. This is something that it still filters, it permits and denies, but this is something that's purpose-built to just filter web-based traffic. And when I say web-based traffic, I mean HTTP. That's it. So a WAF protects web applications by filtering and monitoring HTTP traffic between a web application and the internet, meaning user requests. WAFs specifically protect us from web application-based attacks like SQL injection, cross-site scripting, forgery attacks. So you can see here, right, we have this inline web application firewall that's inspecting traffic and sending back, our 400 errors saying, nope, you can't come here. Okay, last thing not the last thing, but a UTM, kind of old school now. We don't say UTM appliances as much, but everything you just learned about, web application firewalls, stateful firewalls, port security, a proxy server, a jump box, a load balancer, all those functions can all be tied into a single device. So a security vendor can offer us all those protections, and what we would call that is a UTM, a Unified Threat Management System. So UTM, just its book definition, consolidates multiple security and networking functions all within a single appliance to protect businesses from security threats. Now, this is typically talked about in a traditional networking sense, right? Because what we're about to learn in our next session is something called SASE or SASE that also kind of combines all this different, security tooling and SD-WAN. But this, UTM is kind of like an old school way to describe a single thing that I buy that I rack up in my data center that gives me all this security functionalities. Okay, layer 4 and layer 7. So just an easy way to describe how we may filter traffic. Layer 4, the transport layer, this is going to look at the port numbers and filter based off that, or the protocol saying, hey, deny port 80 but permit 443. And that's easy enough. That's pretty much going to say allow all HTTPS traffic. But in that HTTPS traffic could be like a cross-site scripting attack or something malicious, right? So layer 7 allows us to dive deeper, allows us to do that TLS packet inspection and dive deep into what's actually being requested in that HTTP traffic. So we call that layer 7 or application layer filtering, right? Because we're saying layer 4/layer 7 here. That's really referring to how we may filter at like the firewall level. So with layer 4, that could be a stateful or stateless firewall that's just filtering based off, the layer 4 header, where the next generation firewall or a deep packet inspection firewall will filter based off layer 7. All right, now let's move on to the last section of domain 3.2, domain 3.2.3. All right, domain 3.2.3. Now we're going to finish up domain 3.2 by going over secure communications and selection of effective controls. And really what we're talking about here, we're just going to go over different ways that we can securely access our network. So first thing we're going to talk about is a VPN. So a virtual private network, we probably have heard this term before. Originally a VPN was there so that sites that weren't geographically close together could directly, quote unquote, I'm doing air quotes, you can't see me, but quote unquote, directly connect to each other over a broadband internet connection. Meaning I have a site in Phoenix, I have a site in Albuquerque, New Mexico, the one data center, one spoke. I need the spoke to get data center access. So I built a VPN over my internet, my ISP broadband connection that I already pay for, rather than getting like a dedicated circuit there, which would cost us lots of money. That's how it was back in the day. That was the original point of a VPN when it came to like network enterprise. Now we use VPN as a form of protection, a way to mask our original IP headers and also to apply data in transit encryption on our actual data payload. So a VPN, the book definition, establishes a protected network connection when using public networks. It encrypts internet traffic and disguises online identity. And what we mean by that, hiding, masking your headers, your layer 3 header to be exact, just a traditional VPN, enhancing data security and privacy. So this can also deliver us remote access. It can enable users to securely connect to a private network from a remote location. That's like when you have remote workers, they turn on their Cisco AnyConnect VPN client or whatever service they use, and all of a sudden now they can access email and things that they would normally have to access by going into the office. Okay, remote access. So remote access allows users to connect to a network from a distant location. VPN can be used. We can have different application-based protocols like RDP, which I don't recommend enabling over the internet, but it is a way, right? Where we can access our network resources. This enables employees to work from any location. Now, obviously, when you enable remote access in any way you do it, whether it's a VPN concentrator, whether you use things like TeamViewer, you are still connecting over what we call an untrusted network, the internet. So there's always going to be kind of that increased attack surface with any remote access we may use. Okay, tunneling. So tunneling is something that happens within a VPN or within our encrypted, as coming from network background, when we say tunnel, I think GRE tunnel. It's a VPN though. So tunneling is how we make a VPN hide our original IP header. As you can see in this photo, this is something called an IPsec tunnel or IPsec VPN. And in the tunnel mode, we actually add a new IP header and mask our original IP header. So tunneling encapsulates a network protocol within packets carried by a second network, enabling the secure passage of data across an intermediary network. Hate that definition. What really this is, or I might even change that right now, tunneling essentially just adds a new IP header. We call this encapsulation. Think of like an onion, you're just adding layers, right? That's encapsulation. De-encapsulation is taking away layers. We add that additional layer here to mask our original IP header. That's what tunneling is. So it wraps one protocol within another. This can be done at the layer 3 header, which I show here. This can be done at the layer 4 header. This can be done at the layer 2 header. It can be done at multiple different headers. That's why we're kind of being like, when we describe tunneling, it's like, oh, it just wraps one protocol within another, and that's true. But let's get into the meat potatoes of it. This allows us to just hide our original headers. A technology called VXLAN, which I don't think we go over in Security Plus, this does this at the layer 2, right? So anyways, in VPNs, this is commonly used when we're sending data transmissions over the internet, tunneling. Okay, TLS, so the transport layer security. This is the protocol, the suite of encryption from some asymmetric to symmetric encryption to our hashing algorithm to our our non-repudiation. This is what enables us to securely talk over the internet. It requires public key infrastructure. It requires those cipher suites like I just described to protect our data in transit, particularly over HTTP. When you see HTTPS, that means we have TLS enabled and that we can have a end-to-end secure transmission from client to web server. TLS, though, is its own standalone protocol. So even though we see it being added to our HTTP sessions when we talk over the internet, it can be added to other things. We can add TLS for VPNs, for our VPN concentrators, for our remote workers. We can add TLS to DNS. That's something we do in security of DNS called DNS over TLS. It even has its own port number. So TLS is just the way that we can get that data in transit encryption. Okay, then IPsec, kind of already talked about it. That's why I have the same image when it comes to tunneling. But this is a suite of protocols for securing IP. So IPsec, Internet Protocol Security, right? This is a site-to-site VPN technology. We use IPsec tunnels in my day job to connect our different sites over the internet. Typically, this is done right between router to router, router to firewall, firewall to firewall. And it gives us two things, IPsec. One, it's going to protect our headers, and it's going to give us authentication. It's going to encrypt our data, okay? So you can see here there's two different modes when it comes to IPsec. We have transport mode and tunnel mode. With transport mode, we're going to get that data encryption. So we have that data in transit encryption. And then we have something called the encapsulation security payload header. That's our ESP header. That's going to give us authentication from that ESP header all the way to the ESP trailer. When we say authentication, we literally mean it like, oh, there's going to be like a pre-shared key or password between IPsec tunnels, right? From router 1 to router 2 or from hub to spoke. And then we have tunnel mode, which is actually going to add an all new IP header on there that's going to mask the original IP header and also encrypt the original IP header, okay? And then we still have that ESP header as well, providing authentication. So this is VPN support. This is how we configure VPN site to site. One of the ways we do site to site VPNs. Okay, and then a new technology that we're going to talk about. Let's say new, it's been out for a while. Cisco's SD-WAN has been out a lot longer than people may think because it was a company called Viptela, and then it became Cisco SD-WAN. But anyways, SD-WAN is a virtual WAN architecture that is software-defined network. It's an SDN technology, software-defined networking technology, but it allows your enterprise to have these SD-WAN-enabled routers all controlled from a centralized view, a central pane of glass. We talked to the marketing team. And it allows those SD-WAN-enabled routers to choose multiple forms of transport to send data. So with SD-WAN, again, we have that control from a centralized place, so it's an SDN technology, but it allows us to use our MPLS, maybe a 5G network, a fiber connection, all on a single SD-WAN router, and that router can choose different transports, okay? It optimizes our traffic, it's more cost-effective, and it gives us improved performance, while also allowing us to have that centralized management over all of our SD-WAN enabled routers. SD-WAN, again, is one of those technologies, I'm trying to keep it short because I teach CCNP as well, and this is one of my favorite topics. Just know for the Security Plus exam, it's a transport agnostic technology for our WAN routers, okay? It's a virtual WAN architecture that allows our enterprise to leverage any combination of transport services to securely connect users to applications. A long way to say that we have all of our routers controlled from a central place, and now we can get really good granular control over how data is passed for our users. That's it, okay? Okay, another newer technology, something called SASE, right? Or SASE. Again, this is going to be another deep dive that I would love to deep dive with you guys, but let's just go over at high level for the Security Plus exam. So SASE converges network security functions with WAN capabilities to support the dynamic secure access needs of the organization. A whole tongue twister to say SASE is just like the SDN version of a UTM, right? It's going to combine all these different security protocols
for our edge, right? So where our demarcation point is, our users are sitting at our spoke office, and we have that SASE appliance that's giving us our WAN connections. So it's doing SD-WAN. So sending our traffic over multiple forms of transport to access the cloud, to access our applications, to access the internet, to access our data centers on-prem, while also being that centralized single place to provide us with these security functions like secure web gateway, cloud access security broker, and firewalls as a function. So doing firewall services, uh, monitoring connections to the cloud. That's what that CASB is, the cloud access security broker, and securing access to websites with a secure web gateway, and also providing us what this acronym is, zero trust network access as well. So it's an edge computing technology, device, right? It's usually virtual. So I say device, it's a technology, right? That delivers security and network services closest to the source of the data. Again, another deep dive thing that we could talk about, but just know for Security Plus exam, this description is good enough. It converges network security functions with WAN capabilities to support the dynamic secure access needs of organizations. So this is my favorite slide, right? Because this kind of brings it back to the real world, which sometimes these certification exams don't feel as grounded in, like, real world implementations of things. But selection of effective controls. When do I choose to just buy the Palo Alto firewall and put it on my data center, or move things to the cloud and do a SASE? Or when do I move to SD-WAN? What kind of VPN should I use? Should I use something like WireGuard, or should I use something more robust like Cisco AnyConnect, which that's not what it's called anymore, but what are my effective controls and what should I be worried about? And really, this comes down to your organization. This comes down to your organizational goals. It comes down to financing. This comes down to funding. This comes down to how important is security, how important is availability, how important is redundancy, how important is your cost of benefit, meaning, do we spend money on cyber? What's your overall risk assessment? What's your risk appetite in the organization? Have you done an asset inventory to say, oh, we need to harden all these devices? There's so much that goes into it. But to just cap that off, right, selection of effective controls. The selection of effective controls involves in choosing appropriate security measures to mitigate identified risks and protect organizational assets. If I had to add a little thing in there, it would be in accordance with the organizational goals, right? In accordance with organizational goals. Because if you've worked in IT a while, you've done things a certain way in an organization where your change management is very, very, loose. Your change management is, hey, does this look good? Yeah, go ahead, send it. You want me to put it in a maintenance window? Nah, it won't affect anything. And you maybe worked in an organization where your change management is, no. Identify the risk. Let's talk to cyber. Is this in compliance? Let's look at what this may change. How many rollback plans do you have? Write me 5-page documentation on what this is going to change, how it affects our architecture, how much does this cost? Is it open source? We need to vet it more for third-party libraries. You have a whole process to implement a change or a control. So it really just depends on the organization, right? On when you should implement new things, or, what effective controls you should use. And in private sector, this is the big one, right? What's the cost? It's always going to be, what's the cost? And does it help us? Okay, awesome. So that is domain 3.2. I'm going to take a little breather. When we come back, we're going to go over domain 3.3. Okay, now let's go over domain 3.3. In our first section here, compare and contrast concepts and strategies to protect data. We're going to go over different data types and data classifications. Now, I am just going to keep it real with you guys. I like to have a lot of examples that I'm going over this stuff and trying to, get you a little bit more engaged besides just reading book definitions and things off of PowerPoint. For data types and data classifications, I'm not going to have a lot of good examples. A lot of times, sometimes in the Security Plus, it is just, hey, we got to understand this definition. So with that in mind, don't kill me in the comments. Let's go over it. So we're going to go over data types and data classifications. We're just going to go over the book definitions. So let's go over an overview of data types and what it means in this section of the Security Plus. So our objective, understand various categories of data and their significance in security. Categorization of data based on its sensitivity, regulatory requirements, and business value is crucial for implementing appropriate security measures. So what we're saying here is that the sensitivity of data really depends on a couple of different things. Whatever the organization deems it, that's always one. So if your corporation, your C-suite says that R&D project is a $100 million federal grant, so we're going to consider that intellectual property, and we need you to protect this. And then we may have regulatory requirements where we're a hospital and HIPAA decides that for us. HIPAA decides, oh, this is PII and it has to be protected at this level. That's PHI, protected health information, and that needs to be protected at this level when it's on our network, right? Okay, so let's go over these data types. This is just definitions, guys, so bear with me while I read these slides. So, regulated. So this is data bound by legal and regulatory requirements, and it needs stringent protection measures to avoid non-compliance. So this is any data on your environment that has to be in compliance with the regulation put forth by the federal government or your industry or your, I say federal government, I'm based in the US, or really the entity that governs you and wherever that data sits and lives is used by. Some examples. So health records in the US are covered under HIPAA. That's our regulated data. Customer information in the EU can be under what's called the GDPR, the General Data Protection Rights. Those are prime examples of regulated data. So when we're looking at compliance, right, like HIPAA, in the HIPAA guidelines, there's gonna be guidelines that tell you need to encrypt data at this level. You need to have these type of access controls or these type of audit trails. With the GDPR, we have something similar, but it goes more into like data privacy, where it's like you must be able to delete all this user information upon request, right? That's regulated data. Trade secrets. So this is information that provides a competitive edge, is classified as a trade secret. So this is more like something you define, right? Sometimes there may be some legal things behind it. That kind of goes into more like copyrighted data. And when we're talking like, I'm from the US, right? But around the world, where cybersecurity is an international thing, there's not always some legal protection for trade secrets. But how do we protect it just within an organization? So that's non-disclosure agreements, physical security measures, and then of course just our defense in depth, our access control in general, our identity access management, how we set permissions, things like that. Okay, then we have IP, intellectual property. This is creations of the mind, like inventions or artistic works are classified as intellectual property. So there are some protections. Again, this all depends on where you live, where you're doing and conducting business. But we do have what we call legal instruments, such as copyrights, patents, and trademarks that protect the creator's rights, to protect that IP. Where we have a software engineer that built something for Facebook, well, they may be protected as Facebook's property. That's Facebook's intellectual property, even though there was a single man or woman behind there that made this new application or function or feature for this software company, right? But the value of it, why do we protect it just from a business standpoint? Because that's our innovation. Maybe we're a disruptive company that's changing the way an industry does something. We don't want our intellectual property leaked. Okay, then legal information. This is information related to legal proceedings or contracts. It's highly sensitive and requires confidentiality. So legal information, this could literally be you had a data breach and now there's a legal hold on things as we go through the legal process of our data breach because we leaked something, that's super sensitive and now the government or the legal authorities have to get involved. That's legal information. This could be stuff that's protected by attorney-client privileges. So if you're doing cybersecurity for a big law firm, maybe we say, hey, how we store this information about clients needs to be completely segmented, not just by VLAN, but by policy, by micro-segmentation. Maybe we can't put it in the cloud yet, or the public cloud, right? So how we store it, it's, very sensitive. Financial information. So this is information related to financial transactions, records, or assets. Protection, when we're talking about financial information, maybe just of our customers, maybe our employees, we get their W-9s or 1099s, whatever the case may be. We need to protect that. We need to have strict access controls. Maybe we also have compliance, PCI. Credit card transactions are protected under the PCI DSS. That's a regulatory compliance for the credit card and banking and financial industry. So we have to maybe just go off what PCI says we need to do with our financial information and credit card transactions. Okay, now moving on from data types, we're going to go over data classifications. So data classifications, this is going to differentiate levels of sensitivity and handling requirements to ensure proper data protection measures are in place. So the categorization of data based off its confidentiality, integrity, and availability requirements help in implementing appropriate security controls. Now, when it comes to like our governance, so data classifications, we're going to go over terms like private, confidential, sensitive. And these are going to be the terms as defined by CompTIA, but these terms can also be defined by your organization, what they consider sensitive or private or public. And then we have things like your government, where again, I've worked for the US government, And we have actual data classification levels that are part of mandatory access control that have a need to know access, like unclassified, secret, and top secret. So there's going to be data classifications that are set by government entities in your governance, and there's going to be data classification levels that are just what you think, right, as an organization, that, oh, this is private, or, oh, that's public, right? And again, that private versus public can also be dictated by other things like HIPAA, PCI. So sometimes there's governance and compliance when it comes to classification, most of the time, I should say. And sometimes there isn't. Sometimes there's just an organization that says, I think this should be private because I just don't want people to see it, okay? So just go by these definitions here. Sensitive. So this is data whose unauthorized disclosure, alteration, or destruction could cause significant harm, is classified as sensitive information. Confidential. This is data that requires restriction of access to prevent unauthorized disclosure, is classified as confidential. So with confidential, we need to implement strict access control and security. Public. So this is data that can be disclosed without harm or loss, is classified as public. So this is something that you don't mind. It's not a breach, right? It's like, yeah, put it to the public. Put it on our front-facing web portal, whatever the case may be. Put it on our website. I have Wikipedia here as a little image. Restricted. So this is data with very high sensitivity, often subjected to legal or regulatory restrictions, is classified as restricted. So this is saying data classifications that may be part of compliance, right? Like the things I've already talked about, HIPAA, PCI, GDPR. Then we have private. So this is personal data that is not meant for public disclosure, is classified as private. Think of this more as like the actual person. If you have PII, personally identifiable information living on your network, that would be considered more private. PHI, personal health records, that's private. That's something that has to stay private between the provider and you and cannot be disclosed elsewhere. And then critical. So this is data essential for the operation of the organization, is classified as critical. Not to be political, right? But we just, in America, we had our defense secretary talk about critical information in a Signal group chat with the reporter, where those hit times for those airstrikes got leaked prior, that could affect the operation. Just, not to be political, but that's something real world, real time, that critical information was spilled. That, again, could have affected the operations. Now, it doesn't have to be as serious as like a military strike in a third world country, attacking terrorists. It could just be something in your enterprise, right? That's critical information that your competitors find out about it. Well, there goes your IPO, right? Or something like that. Okay, so that was domain 3.3.1. A little bit quicker than our other ones, but again, we just had to learn those book definitions. So now let's move on to the last section of domain 3.3. Okay, continuing on with domain 3. Now we're going to go over general data considerations and methods to secure data. So we're really going to go over things that, again, we kind of talked about. We're going to go over a high level, the different methods to secure data. And then we're going to go over the different data states, things we have to think about when it comes to our overall data. And again, I'm speaking in, holistic terms, data being all of our user traffic, enterprise traffic, anything on our enterprise, and also how geolocation can affect it. So general data consideration, a little overview. So we have to understand various aspects affecting data security throughout its life cycle to actually have a comprehensive protection strategy, our defense in depth plan. So factors such as the data state, sovereignty, and geolocation play a role in how we, do our, how we define our risk, how we define how we need to protect our general security policies, whether that be logical or physical, our defense in depth, the life cycle. So if data moves from our storage off to the internet, how do we protect it in those transition states? So data states. We have 3 data states we're going to talk about in the Security Plus exam. We have data at rest. That is data that is stored and not actively being processed. Guys, this is your hard drives. This is our storage shares. When data is not actually doing anything, we're not using it, or it's not being transmitted. We call that data at rest. So how do we protect data at rest? It's going to be things like full disk encryption. And then, of course, physical security, making sure people can't come in and just take our workstations, right, in our office. Data in transit. So that is data that is moving through the network, whether that be internal on our enterprise, out to the internet, external into our enterprise, whatever the case may be, that is data that is transiting a network. And we have transmission control protocols that we need to protect. So we use things like TLS to prevent interception and unauthorized access, which we talked about, right? Data in transit, we also need to have authentication and encryption. So that's HTTPS, that's IPsec tunnels. Or adding TLS to other protocols like FTP, you can add TLS. Using secure remote management protocols like SSH, disabling, remote desktop protocol. Data in use. So this is data that is actively being processed or used by applications. So this is like I have Canva pulled up. I have OBS Studio recording me right now. Those are applications that are actively being used by my workstation. The CPU and memory is being used to run these applications. That is data in use. We can also secure our data in use as well. So state-specific strategies, just a term that CompTIA wants us to learn that says, hey, you don't protect data in use the same way you do data at rest. Some things may be true, right? Like least privilege is always going to be used no matter what when accessing any data, whether that's data at rest, data in use. Encryption's one way to protect it, but we may have different encryption for data in use than we do data at rest versus data in transit. So how the state of our data determines how we protect it is really what that statement is saying. Okay, other general data considerations, we have data sovereignty. So how do we protect it? So we know we have these logical and technical controls. We have encryption, just to name a big one, right? We have hashing, we have obfuscation, masking, all these different things we can do. But why? Why do we do it? Well, obviously, it's kind of a broad question. Well, this is a cybersecurity course. What do you mean why? It's our whole job as cybersecurity engineers. Yes, you're right. But is there some sort of body, some sort of governing body that tells us we need to? And yes, there is, right? In America, we have things like PCI, NIST, FedRAMP for SaaS applications. We have things like HIPAA that protects our health, right? PCI in the financial industry for credit card transactions. So we have this data sovereignty where we say we live and operate our business and essentially our data in this region. So we have to abide by these laws and these regulations. We call that data sovereignty. So this is the concept that data is subject to the laws and governance structures of the country it is stored in. So organizations must adhere to local data protection laws and regulations, and that's something for you to understand as a cybersecurity professional. And really this happens, what sector, what are you in? I work in the defense, so we always go by the NSA standards or NIST standards. That's something easy I understand. If I transition to work at a healthcare provider, I'd have to learn HIPAA, right? This affects how data storage decisions regarding where to store and process data. And then of course, if we're international, if we have customers in the EU and we take their data and put it in the US, do we still have to abide by the GDPR? Short answer is yes, but that's something we have to think about if we're an international company. And then of course the geolocation, so the physical location where data is stored and processed, that affects us, right? Kind of similar to data sovereignty, if I'm operating in California versus a data center in Arizona, is there anything local I have to think about? And yes, there is. There's a California protection rights. I can't think of the actual law now, but California has additional state rights. So this has impact on the sovereignty. Location strategy. So we have to factor some things in besides just, the data sovereignty when it comes to geolocation. What does it cost? How much is power there? Where are the legal requirements? Is it far enough away for natural disasters? If I put a data center in Tampa and then my backup data center in, let's say, Orlando, well, maybe, that's not far enough away. Maybe a hurricane's going to hit both those cities hard, right? So you just never know. You never want to place data centers too close to each other, or I'd say data center, but your redundant site too close to each other. So that matters when it comes to geolocation as well, if you're worried about natural disasters or blackouts. Okay, now we're gonna go over methods to secure data. So we're gonna go over a bunch of different protocols, technologies that we've already talked about that secures our data. So let's get into it. So geographic restrictions. So implementing geographic restrictions involves limiting where data can be stored and processed based on geographical boundaries. This is just saying, hey, look where it's gonna be stored. Do we wanna comply with those legal requirements? No, store it here. That's all it's just saying, just the geographic restrictions. Encryption. So this is like, you go to someone on the street, you say, how do you protect data? I'm doing like a street interview, right? Like you see on social media. How do you protect the internet? People are gonna say VPN and encryption. Now, obviously us as cybersecurity engineers, we need to know the different ways encryption can affect us, symmetric versus asymmetric, how encryption gets involved with digital signatures that provide us non-repudiation, how it gets involved with PKI, whereas encryption, how does it help us? But this is just a method to secure data, whether it's in rest, in use, or in transit. Encryption can be used to protect our data, change our plain text to ciphertext, stop interception attacks, and overall just protection, right? It gives us confidentiality. We look at it from the CIA triad. Encryption gives us the confidentiality of our data. Okay, hashing. So hashing gives us integrity. And again, I'm being high level because we've deep dived into this more in domain 1. So I don't even need to stay too long on this. But hashing gives us integrity. It also gives us non-repudiation, and we want to use strong hashing methods. Just like everything in security, if we can have a stronger algorithm, a bigger bit key size, that's going to be more secure. Same with hashing. Masking. So data masking involves obscuring specific data within a database to prevent unauthorized access while allowing the data to remain usable. So sometimes in our databases, we encrypt that data. It's not usable, right? We have to go in and unencrypt it. Well, then we just turn it into plain text, then it's in use, right? And then it's in use and plain text being transmitted across the network. Where masking says, hey, for whatever reason, we can't encrypt this database, so we're going to mask it as a way to give us some protection to the most sensitive data in that database. Tokenization. So tokenization involves replacing sensitive data elements with non-sensitive equivalents, known as a token. And if that token gets stolen, it can't be exploited because that token is going to correlate to the sensitive data that sits at some server somewhere that's going to correlate it for us. And as an attacker, I do a man-in-the-middle attack, take that token. I don't have access to that server, so I have no idea what this token represents, right? This is widely used in securing payment card information like, your Apple Pay. Does Android have that? Google Pay, maybe? I don't know. I haven't had an Android phone in like 10 years, but tokenization. Replacing sensitive data with non-sensitive equivalents. Obfuscation. This involves deliberately making data or code ambiguous or confusing to prevent unauthorized, not access, but understanding. We just make it so it can't be understood. Not that it's not readable like ciphertext, it's just not understood. Then, of course, segmentation. I talk about this a lot, but network segmentation, whether it's traditional, whether it's micro-segmentation in the cloud, whether it's north to south or east to west filtering, segmentation reduces our overall attack surface. It helps us with breaches. When we segment, it helps us isolate, and segmentation can be done through subnets, virtual LANs. It can be done with firewalls, with our different firewall zones, our outside, inside, and DMZs. Outside zone being untrusted, inside zone being trusted. It can be done with those VPCs and VNets I already described in the cloud, or that micro-segmentation. Okay, then permission restrictions. So something that's simple, right, is what's our read, write, and execute permissions? Who are we allowing access? This also dives into identity access management, which I've talked about. So sometimes we need to set permissions and restrictions on our data. So permission restrictions involve implementing policies and controls to ensure that only authorized users have access to specific data or systems. Okay, awesome. So that was domain 3.3. Now let's move on to the last section of domain 3, domain 3.4. I'm gonna take a short break, then I'll be right back. Okay, let's go ahead and finish up this crash course for domain 3 of Security Plus by going over domain 3.4. So this is explain the importance of resilience and recovery in security architecture. And in this section, we're gonna go over high availability, site considerations, and capacity planning. So this is all going to be about the availability of our systems. How do we architecture our network, our domain, our enterprise to make sure we're highly available for our users, for our customers, and just for our whole enterprise. And we're going to go over different site considerations. We're going to go over ways to deliver high availability to our network when it comes to our network infrastructure or our systems. And then we're going to go over platform diversity, just multi-vendor environments, and how we do capacity planning in terms from the cyber perspective. So high availability. Let's define the term high availability because I've said it a lot. So high availability refers to systems designed to be operational and accessible for a long duration without interruptions. All it means is that we stay online. We're delivering 99.99999% of whatever we're providing, whether that's providing something to the customer or to our own users. We're highly available. Now, that's easy to say, but now how do we implement? How do we design things? What are the methods to get us there? And why is it important? For a business that relies on uptime, things like social media, for example, a company like YouTube, that is everything. It's uptime. It's obviously the platform, how easy it is, marketing, all that, of course, right? But it comes to cybersecurity, is it highly available? If that database gets breached, am I down? Are we down? And if we are, and that's what we tell our C-suite, they're gonna say, no, we're not. That database gets breached, you coop over to the site in Europe and we stay up, right? Even if the latency is a little bit higher for our US users. So it's essential for businesses to stay online. So a couple ways we get high availability. So load balancing, we talked about this on the network, right? Load balancing and clustering are methodologies aimed at distributing workloads and computing resources, enhancing the performance and reliability. So load balancing focuses on the network. This is on efficiently distributing incoming network application traffic, which I already talked about, so I'm not going to deep dive again. If you haven't heard me say this, sometimes security plus exam objectives do like to repeat just a little bit, is what it is, but I will talk about clustering. So clustering is when we combine that compute resource. Load balancing more on the network, right? Distributing network incoming traffic and network traffic. With clustering, this is going to involve compute being clustered together, being pulled together, being scaled up properly. So this involves linking multiple servers so they function collectively as a single, more powerful system. You know, this is modern architecture too. Having all these containers in a Kubernetes cluster hosted on a multi-cloud environment, that gives us high availability, or containerizing applications at the edge, right? That's clustering. So load balancing, optimize resource use and system throughput on the network. Clustering is more geared towards maximizing system availability, right? The actual system itself. Now let's get into site considerations. So imagine you have a data center that runs your Active Directory forest, all the services you need to stay online as an enterprise in that data center. We'll just keep it internal. I don't want to get into like, oh, if you have a web server that you host locally, that's not really modern way of doing it. Things go in the cloud now. But anyways, so we have that data center. And we say, hey, our data center is in Tampa, Florida. Every year we have hurricanes. We need another site. We need redundant sites in case we go down for power, natural disasters, or whatever the case may be. So what are these type of sites, backup sites that we have? So we have 3 different site considerations we're going to talk about: hot, warm, and cold. So a hot site is an external facility that is fully equipped and operational to take over business operations immediately. Under minutes, you know, it's seconds. Maybe there is no downtime. That is a hot site. That is a data center that's ready to take over every function and service and application for our enterprise. Now, obviously, this is the best option if money is no option, right? If money's not a consideration, as in we don't have a budget, we have unlimited money, we go with the hot site for the most highly available, highly redundant site. So cost, operating hot site involves significant expenses. You were just running 2 sites essentially, right? Whatever you do to your primary data center, you do to your hot site. That's essentially what it is. Then we have a warm site. So a warm site provides a middle ground between a hot and cold site. It's equipped with some but not all the components necessary for a instantaneous activation. So with a warm site, obviously it's a little cheaper because we're not as maintained as we are a hot site to take over right away. However, it still costs a little bit. They're generally equipped, ready to go with maybe just configuration change. Maybe we just need to go in there and, you know, do some configuration change, make sure things are now rolling over to this warm site, okay? So with the warm site, you go and Google it right now, it says 12 hours, but that's from the ISC squared side. This is CompTIA. For a warm site, this is maximum 24 hours. If it goes past 24 hours, it's not a warm site to be operational again, okay? And then a cold site. So this is just a backup facility. This is not a backup data center with things ready to go right away. This is gonna take time. They require setup, they require install, they require system configuration. Maybe the equipment's there, maybe power's there, maybe HVAC is running, but you gotta rack and stack and configure. That is a cold site. And obviously it's the cheapest, but it doesn't, you know, you're down, right? If you have a primary data center and your backup's a cold site, you have like 2 options. Wait till the primary data center comes back up online, because that cold site will take, probably take longer, right? So that's what a cold site is. Okay, more site considerations, geographic dispersion. So not only does this talk about like compliance, right? Which I beat you over the head with that. If you're in the EU, GDPR, if you're in America, these laws. So geographic dispersion, we have to think about our data sovereignty, our governance, our compliance, but also our users, right? In this section, we're talking about being available. So if I have a big user base in Southeast Asia and I'm hosting servers, let's say, what would be the farthest away? Would it be Europe? I don't know, somewhere in here, like, you know, in Northeast Canada or in the middle of America, I should say. Is that the best way to disperse, you know, our applications, our web servers? No. If we have a huge customer base or user base in Southeast Asia, put some servers over there. Deploy to a cloud data center over there. So geographic dispersion helps us be highly available to our users. It helps us with business continuity. It helps us with natural disasters at a certain site that won't be happening at another site 1,000 miles away. So geographic dispersion helps in minimizing the impact of localized events. It helps us with compliance. Maybe, maybe we don't want to be following all these EU rules. So we host some servers in Asia, right? Or Africa, right? But hey, compliance, right? Facilitates adherence to data sovereignty laws or regulatory requirements by distributing data across different legal jurisdictions. Helps for our business continuity as well. Okay, another way we can remain highly available that may take a little bit more expertise, may take a little bit more time, but something called platform diversity, where if I am a complete Cisco shop, all my switches are Cisco across my entire international enterprise, and a major vulnerability comes out from the Cisco switch, guess what's vulnerable? Every single network switch in my environment. So sometimes platform diversity, where we use different vendors, can help us reduce the risk. Maybe it can reduce our attack surface. Sometimes it increases, but it can give us, that ability to say, oh, if this one goes down, there's a major outage on AWS, but we also host in Azure. Guess what? Those Azure-based services that are hosted in Azure, they're up. So utilizing diverse platforms minimizes the impact of platform-specific threats and reduces the likelihood of simultaneous system failures. And you have that vendor independence. You don't have that vendor lock-in. Okay, multi-cloud systems, just talked about that. Why they make this two different things, I don't know. I kind of get it though, because they're still thinking on-prem is platform. You going with this Red Hat Linux or Debian-based Linux, Cisco switch versus Juniper router. I get that. Multi-cloud systems are the same thing though, right? Maybe you want to host things across all the major cloud providers because you want that redundancy. Or maybe there's some things AWS does better than Azure. Maybe you want Azure for the identity access management, the Entra ID to integrate into your Active Directory, your B2B, whatever the case may be, and you want to put compute resources on AWS. So you have that multi-cloud system, which saves you from a single provider outage. Okay, continuity of operations. This is the practice of ensuring that essential business processes continue during and after a severe disruption. So just, hey, how do we make sure we have continuity operations? When we build that hot site and you tell me it's good to go, how do I know? Have we tested it, right? So have we tested our continuity of operations? Okay, capacity planning. So capacity planning is, are we ready to scale up at right of bang? Meaning, I'm Crunchyroll. I like this example, right? It's kind of, I wouldn't say it's showing my age, right? Even though this happened like a year ago. I made these slides like a year ago. Crunchyroll, we're a streaming service for an anime. And the whole community is expecting, they're excited for this new episode of One Piece where Luffy goes into Gear 5. Are my servers ready for that? Crunchyroll thought so, and it turned out they crashed the site because so many people were trying to watch that episode. So are we doing our capacity planning? How are we doing it? And are we prepped for it? How elastic are we? Do we have the technology to properly scale up? Do we even have the infrastructure to scale up? That is all part of our capacity planning. Do we have the staff even? There's a human element. Do we have enough people on staff on call in case of something happening that we need to upgrade or upscale our capacity? Okay, awesome. Now moving on to the last section before we get to questions, let's finish up Domain 3.4. Okay, let's go over our last section for Domain 3.4 and finish up the lecture portion of our Domain 3 crash course for Security Plus. Now we're going to go over testing, backups, and power. So how do we test? How do we test to make sure that our systems are highly available? How do we test to make sure that really anything we do, our disaster recovery plan, our incident response plan works? We do it with testing. So let's go over a couple different exercises or testing that Security Plus exam wants us to know about. So a tabletop exercise. These are structured discussions used to examine and evaluate an organization's plans and capabilities in a simulated crisis situation without using actual resources. So a tabletop exercise, this is to validate the effectiveness of plans and procedures, but really the important thing of it is we clarify the roles and responsibilities of everyone involved. So think of a tabletop exercise as bringing every stakeholder in. And this is, something you put on the calendar. Blah, I'm not gonna get into the boring details of how we get a meeting together in corporate America. But we have the IT team, development team, cybersecurity, and other stakeholders from other departments. And we say, hey, do you guys know what to do if there's a major data breach? Well, me as the CISO, let me explain. Let's have everyone go in the room, see if you know your role. And if you don't, in a constructive manner, let's go over all of our roles and responsibilities if a disaster happens on the network. That is a tabletop exercise. It doesn't use active resources, doesn't take anything down, there's no failover, there's no maintenance window that needs to go into play. It's all just scenario based. Let's talk about it. Let's put it on the whiteboard. That is a tabletop exercise. Now, a failover in simulation testing. This does involve evaluating the resilience and performance of systems by simulating failure scenarios and validating our backup systems, our continuity of operations, or anything we want to actually technically test, right? So a failover. This ensures that secondary systems or components can seamlessly take over in case the primary systems fail. It's a failover test. So this is gonna, take something down. We have a simulation. This involves creating a controlled environment to mimic real world resources. So this is not going to take down production, and this will still allow us the validation of system functionality. We can have a whole sandbox, right, to do simulation testing. Okay, then we have parallel processing testing. This involves conducting operations in a real-time environment alongside existing systems, enabling a comparison of performance without impacting ongoing operations. So you may say, what's the difference? Simulation? It's just something that can run side by side, right? It is kind of like a sandbox environment as well. And let's go over our backups. So we have on-site, off-site, our frequency, and do we encrypt our backups? So think of backups as literally like a snapshot of a VM, backups of our storage area networks or whatever network we may have. So on-site / off-site. So on-site backups provide quick access for data recovery while they may still fall victim to the same disaster, right? If we have on-site backups and there's a power outage, where are our backups? They're also gone. While off-site backups, those are actually essential, right? Because we're backing up in the same data center that can fall victim to the same disaster. What good does that do us, right? When it comes to being available, right? So off-site backups are essential for protecting against local disasters. Then the frequency. Backup should be performed at regular intervals. Now, this is going to, again, be based off your risk appetite, the organization, but there's a general way we do backups. Full backups weekly, incremental differential backups daily. This can be based off your RTO or RPO, your recovery time objective, your recovery point objective. And this is to minimize data loss and ensure the most recent data is recoverable. And then the backups that we take, when we back up our data, we also need to protect that. We don't just encrypt the data that is our primary, we encrypt the secondary too. We want to encrypt and protect our backups as well because we don't want the backups to get breached. Okay, snapshots, recovery, replication, and journaling. Let's go over some of these. So a snapshot, this is what we call a point in time, right? So this is generally geared towards VMs. And that's what we say. You say we take a snapshot, we're talking virtualization, where we take that VM on a Monday at 9 a.m. and we say, we're about to upgrade a third-party application, our antivirus on here, on the DHCP server. Now, before I do that, I take a snapshot of it at a good point in time where it's working, it's fully operational. Then I do my upgrades, and then I start getting calls from users saying they can't re-access the internet, and help desk tells you DHCP is down because we're getting a PIPA addresses on our computers, right? We're not getting IP addressing. You say, okay, that upgrade to my antivirus did something, and now this DHCP server is not working. I'm gonna roll back. I'm gonna go to that snapshot I took, and that's gonna rapidly restore my system. Recovery. This involves strategies and plans to restore systems and data to operational status after a loss or corruption. So this is just this isn't a technology like snapshots, a specific thing. This is just saying, how do we recover? Then replication and journaling. So this ensures that data is continuously copied to different locations. Replication, that's what that is. That data is continuously copied to different locations. And with replication, we can get a little deeper even. We have synchronous versus asynchronous, where synchronous is it's constant. I upload a file to a shared drive. With synchronous replication, it's automatically sent to my backup shared drive in London somewhere. I'm working in America, right? Where asynchronous, I'm backing up to my offsite storage area network in London, and again, I'm in the US, every 15 to 30 minutes. That's asynchronous, where it's not automatically. And then journaling is how we meticulously track that, right? So journaling is not the actual replication of data being sent across the wire to another backup, another storage area network. Journaling is, okay, this happened at, it's logs essentially, right? Just another way to describe our time tracking and logs. Saying, oh, this happened here. This happened at this time. This happened at this time. Okay, and the last one we're talking about is power. So how do we back up our power? Because again, in data centers, maybe we want that power diversity. We have multiple power lines coming in. That's something that we can have. So if one power company goes down, maybe we have a secondary. I wouldn't say it's rare, but something we can do. If we just have a single power line coming in, Maybe we have a big generator with an automatic transfer switch or ATS that says, hey, if we have a blackout, a full blackout, a sustained blackout, turn the generator on. Then we have something called UPS, which will probably, they're just batteries. But we have a UPS in every single data center rack that can hold the capacity of everything in that rack for at least 30, an hour, 2 hours. They're not a sustained recovery or power backup, right? That's an UPS just keeps you on long enough to hopefully you get the power back on. Now, an UPS can also help you with rolling brownouts though. Because imagine you're in an area or a country, I've been in these countries before, where there's brownouts. So power goes down and comes back up. Or we're not getting enough power, right? There's surges or whatever the opposite of a surge is where power gets lower, right? But you're still getting some power. That can mess up your systems, right? But it's not enough for a generator to take over because it's not a sustained blackout, right? So you don't want the generator to come on and then a second later the power's back on, generator comes off. You don't want that back and forth, right? Generators are for sustained blackouts. So what an UPS can do is it can temporarily give you enough juice in the event of a brownout in these countries where power isn't sustained to keep systems online. Okay, awesome. So that is going to be it for the lecture portion of Domain 3. I'm going to take a pause and let's go ahead and go over our questions. What's going on, everybody? Johnny Bannon here, the networking guru. In today's video, we're going to go over Domain 3 of the Security Plus SY0-701 exam. We got a couple questions we're going to go over. It'll be in the title. Let's jump into it. And these are available to purchase at our website at trepatech.com. Do not forget to like and subscribe. No more intro, just questions now. Okay guys, so I'm at my learning management system here on our academy.trepatech.com, and we're going to be going over our Domain 3 questions. So let me search this up. We got 40 questions we're going to go over here. Let's go ahead and begin. Let me zoom in just a little bit, make this a little bit more readable. Okay, question 1. So how I'm going to do this, guys, I'm going to read the question. I may read the answers sometimes, depending how long they are, if I'm really analyzing it. We'll answer the question, and then if needed, we'll go into the explanation. So this is going over Domain 3 of the Security Plus SY0-701 exam. So question 1. Which of the following presents the greatest risk when handling non-human readable data? So the greatest risk when handling non-human readable data. So again, this is going to be something that's maybe encrypted, maybe like a barcode or something like that. Something that the human mind, the human eyes cannot read. Something that's not just plain text data, essentially. But it's not always just ciphertext. They consider non-human readable data, again, like a barcode or something like that. So let's see here. A, the inability of security tools to detect unauthorized modifications in encrypted data. That is something that is true, right? Like if we're monitoring data in transit and it's end-to-end encrypted HTTPS, and we're not doing like TLS, deep packet inspection, so de-encrypting and re-encrypting, we can't really see what's in that data payload, right? We can't say anything beyond just our layer 4 header or the port number 443, right? So I'm probably going to go with A here. Let's read our other options. B, increase susceptibility to phishing attacks. No. C, the use of standardized data formats that make the data easier to analyze. That's not a security risk, I would say, because it's not always true that it's in a standardized format. Lack of regulation. I wouldn't say that. I mean, obviously regulation always depends on where we are, our data governance. So I'm going to go with A here. The inability of security tools to detect unauthorized modifications in encrypted data. Show our explanation here. Pause the video if you'd like to read that. Question 2. Which of the following best describes IP, intellectual property, in a cybersecurity context? So again, IP is going to be something that we want to protect. That's something we created in our environment or even as a personal inventor. So I am going to go with C here. Legally protected creations such as patents, trademarks, copyrights, and proprietary algorithms. You can switch out algorithms with technologies, protocols, anything that's can be protected. That gives your company a competitive edge too as well. So there's the explanation. Pause the video if you'd like to read. Question 3. Which of the following best describes a primary security concern when implementing software-defined networking? So software-defined networking is going to separate the control plane of all of our networking infrastructure and centralize it. So that control plane becomes centralized in a single pane of glass, really a centralized device. So that's what SDN does. And I mean, it's a lot more complicated than that, right? but versus traditional networking where the control and data plane sit at each individual device, and we have to manage and set up policy and routing security at each individual device, where with software-defined networking, that controller, we call that controller-based networking, where a single controller defines all your routing policies and profiles for all your network infrastructure. So there is encryption in that. We can enforce the access control with SDN, right? Makes it a little easier. Reduce network segmentation? No, network segmentation doesn't go away, right? It just means that how we modify is at a central place, but that doesn't mean the actual data plane can't be segmented. So I'm gonna go with B here. Centralized control plane as a single point of failure. And that is true, right? I guess you can consider it a single point of failure. Like if my SD access platform, like Cisco Catalyst Center goes down, then yeah, right? Like I can no longer do my policy changes. Doesn't mean the data plane is down. Doesn't mean we're hard down, but we're essentially down if that one device goes down. Pause the video if you'd like to read the explanation. Question 4. Which of the following best describes a tabletop exercise in security testing? So tabletop exercise, that is going to be where we're all getting around in a room and we define our roles and responsibilities. We're not actually doing any like simulation. We're not taking anything down or actively on the network. So I'm going to go with D here. A discussion-based scenario where teams walk through a hypothetical security incident without disrupting operations. And that is what a tabletop exercise is. Pause the video if you'd like to read the explanation. Question 5. A healthcare organization stores patient medical records and classifies them as restricted data. That's PHI. What does this classification imply about security requirements? So it's a regulatory compliance, right? So when we look at personal health information, because that's what essentially we're describing here, that is protected under something called HIPAA. And how we store, how we use, how we send that data, what we do with it, that protected health information is going to be a regulatory compliance, right? Due to HIPAA, our HIPAA laws. So we're going to go with A. Access is tightly controlled and limited only to authorized personnel due to regulatory compliance. Pause the video if you'd like to read the explanation. Question 6. Which of the following best describes the purpose of tokenization as a data security method? So tokenization is going to replace something sensitive with a non-sensitive, what we call equivalent. So let's take a look. Doesn't convert. I would say D and B is what we're looking at here, right? It doesn't do encryption at all. Doesn't hash, doesn't encrypt. So B replaces sensitive data with a unique randomly generated value to reduce exposure risk. I mean, a token is still exposed. A non-sensitive token will still have the same exposure factor as your regular data transiting a network, right? It's not like all of a sudden it's not transiting, right? It still has the same exposure. And then we look at D here. It says it hides sensitive data by substituting it with similar looking characters that are difficult to reverse engineer. That's not the point of it. I'm going to go with B here. I don't exactly like that answer. I don't think it's a one-for-one definition of tokenization, but that's okay, right? What best describes it? So we're going to go with B. It replaces sensitive data with a unique, randomly generated value to reduce exposure risk. Pause the video if you'd like to read the explanation. All right, question 7. A company needs a disaster recovery site that is pre-configured and can immediately take over operations in case of primary site failure. Which of the following should they implement? It's easy, right? Immediate takeover, that's a hot site. That is a hot site. Hot site's fully operational. Pause the video if you'd like to read the explanation. Question 8. Which of the following best describes how high availability impacts security in an enterprise environment? So high availability, right, that gives us redundancy. It ensures that we remain operational even if we got breached or malware is detected, or if we have a natural disaster at a site, other sites should take over, right? Or if we have a single router goes down, we have our HSRP repair there. So I'm going to go with B here. It ensures systems remain operational during attacks, but it can increase attack exposure. And what we're saying there is that if we have one system online and we add an additional system, that's another system we have to harden and take care of. So it can increase attack surface, but it makes sure that if we stay operational. That's the thing of it. We stay operational with high availability. Pause the video if you'd like to read the explanation. Question 9. Which of the following security risk is most associated with containerized environments? So containerized environment, that's another virtualization technique that uses a shared kernel and what's called container images rather than entire operating systems that we'd seen regular virtualized environments, right? This isn't not ESXi, this isn't a hypervisor, this is a shared kernel with a container engine like Docker, deploying container engines with the dependencies and binaries and libraries already part of that container image to deploy an application, like a web server. So because of that, we have that shared kernel. So I'm gonna go with A here. So it has encryption, we have security logging, and we have network segmentation with containers as well. Maybe a little bit more difficult to implement if you've never done it before. Not more difficult, it's just different, right? If you're not used to containers. But our answer here is A. Increased risk of kernel exploits due to shared operating system resources. Pause the video if you'd like to read the explanation. Question 10. Which of the following best describes a failover test in the context of disaster recovery and resilience? So a failover test is actually going to be taking something down, right? So a failover test is there's a system, whatever it is. It's going to be in production though, and we're going to see if our backup system can actually take over. So we're going to go with A here. So temporarily taking down the primary system and switching to a backup system to verify operational continuity. Pause the video if you'd like to read the explanation. Question 11. A company is deploying SD-WAN to replace traditional MPLS connections. What is the primary security concern when implementing SD-WAN? So let's see. It doesn't require on-prem hardware. It can implement policy-based routing. Relies on direct internet access. I mean, doesn't every WAN connection? Believe it does. And SD-WAN by default, at least for Cisco SD-WAN, uses IPsec. Uses IPsec to actually create its tunnel connections. So A is not it, right? SD-WAN relies on direct internet access. I guess we can go with B, but I mean, MPLS, well, I see what it's saying. So SD-WAN, right? Your controller somewhere in there is going to have access to the internet, but that access could still be MPLS backbone in the ISP. I think what it's just trying to say is that like, as a business, maybe we have a dedicated circuit that's provided to us, right? It's an MPLS connection in the back end. It's a layer 3 MPLS connection. But with SD-WAN, we don't necessarily get rid of that. SD-WAN is just a way to control that router. And then we can add in additional transports like LTE, 5G, or like Starlink, or like a different fiber broadband connection. So, man, I might even just get rid of this question. I do not like it, but I understand what it's saying, right? It has direct internet access, so it can increase exposure to threats. All right, we'll move on from that. All right, question 12. Which of the following best describes private data in the context of data classification? So again, we're going over what CompTIA describes as private, right? These different data classification levels. So which of the following best describes private data in the context of data classification? So when I think of private and the way that CompTIA thinks of it, I'm thinking like my credit card information, my social security number, private stuff to the customer or to the exact user, private to them that needs to be, just to that person. So I'm gonna go with B. Data that contains personally identifiable information, PII, and is restricted to authorized access. Pause the video if you'd like to read the explanation. Question 13. Which of the following best explains the purpose of parallel processing in disaster recovery testing? So again, another disaster recovery test. So the purpose of it, right? So this is when like a parallel processing is when we have our primary and our secondary is running at the same time, side by side, in parallel. So this one's going to be A. It allows an organization to run a secondary system alongside the primary system to verify functionality without disrupting operations. So we're not taking down anything in production to test something, right? Pause the video if you'd like to read the explanation. Question 14. Which of the following is a key security benefit of using a multi-cloud strategy for continuity of operations? Okay, so it doesn't simplify. It doesn't ensure like security policies remain identical. They'll be similar, but it's not going to be a one-for-one match, right? Same purpose, But I'm going to go with B here. It reduces the risk of vendor lock-in and increases resilience by distributing workloads across multiple cloud providers. Pause the video if you'd like to read the explanation. Question 15. A security administrator needs to implement a site-to-site secure communication channel between two corporate offices over the internet. Which of the following solution is the best choice? We're going to go with C here. That's an IPsec tunnel mode VPN. IPsec does our site-to-site connections over the internet. Pause the video if you'd like to read the explanation. Question 16. Which of the following best describes a security advantage of using infrastructure as code? So it's consistency, right? So if we have security configurations like a security technical implementation that needs to be the same across all of our network infrastructure, infrastructure as code can help us establish that and deploy that in an automated way with consistency, right? Because it's one code base, one master repo of code. Pause the video if you'd like to read the explanation. Question 17. Which of the following best describes why regulated data requires strict security controls? So I'm going to go with B here. It is protected by governmental or industry-specific regulations that impose penalties for mishandling. So that is regulated data. Just data that has to be in compliance with something, industry, government, whatever your regulating body, your governance body may be. Pause the video if you'd like to read the explanation. Question 18. What is the biggest security concern for an organization that uses a system with inability to patch due to legacy software? So does it increase the risk of 0-day? I've seen this one. I remember looking at this one. I don't like it. Every system has the same level of risk for 0-day. That's why it's a 0-day. Now, if this answer was 0-day vulnerabilities cannot be patched, that would be correct, right? And I think A is going to be the answer because high operational costs due to frequent software updates. EOL, there is no software updates, right? There is no software updates anymore because the vendor's not doing them, right? I don't like this question. I'm going to make a note of this question. But anyways, you can pause the video if you'd like to read the explanation. Question 19. Which of the following best describes a security challenge unique to industrial control systems, ICS, and SCADA environments? Remember, this is our OT, right? This is our operational technologies that differ from our informational technology that represents like our regular enterprises that we're used to. So which of the following best describes security challenge for ICS and SCADA? We're gonna go with C, right? They always have legacy systems on there because they're built to last. My example is always like a dam. A dam built in the 1980s. We can't just replace that computer right away. We can't just replace the software and hardware right away for that. Things may not be compatible, so you just have to deal with legacy equipment. So the correct answer is C, long life cycles and legacy systems with limited security updates. Question 20. Which of the following is a primary security concern when using a decentralized IT architecture compared to a centralized model? So decentralized is when you have all these different nodes agreeing with each other versus a centralized architecture, which is a single service or server. So we're going to go with B here. Difficulty in enforcing uniform security policies across all systems. Pause the video if you'd like to read the explanation. Question 21. A company implements an intrusion prevention system in its network. How does an IPS differ from an IDS, intrusion detection system, in terms of security functionality? So remember, an IPS is going to actually block, while IDS only alerts and only monitors. Pause the video if you'd like to read the explanation. Question 22. A security administrator is implementing a network segmentation strategy using different security zones. Which of the following configurations provides the most security for a web server handling external requests? So we're going to go with C here, putting that web server in a screened subnet, and that screened subnet can have additional monitoring, but can also talk to both the internal and external network. It used to be called a DMZ. Pause the video if you'd like to read the explanation. Question 23. Which of the following best describes data in use and the security challenges associated with it? So this is going to be data being actively processed by our RAM, our compute resources. It's not going to be stored or transmitted. So we're going to go with A here, kind of an easy one. But it's vulnerable to attacks like RAM scraping and other data and use attacks, right? Keyloggers, advanced malware that's not like file-based, installing files on your C drive or your operating system. Pause the video if you'd like to read the explanation. Question 24. A network administrator wants to enforce authentication before allowing any device to connect to the corporate network via Ethernet. Which of the following security mechanisms should be implemented? So this is going to be 802.1x. That's the only port security I see on there that does network access control. Load balancing does not, proxy servers do not, and jump servers do not as well. So it's going to be A, 802.1x authentication with extensible authentication protocol for port-based access control. We should have added some radius in there as well, some AAA, but that's okay. Pause the video if you'd like to read the explanation. Question 25. A security team is deploying an intrusion detection system to monitor network traffic without impacting performance. Which of the following device attributes should be used? So we don't want any impact, okay? So we want a device that is not in line. That's how I see this, is not in line, and that is not actively going to stop anything, right? So I'm already thinking passive, and I'm already thinking not in line. So we're going to go with tap and monitor. So it's going to be A, passive mode with a tap/monitor implementation. Pause the video if you'd like to read the explanation. Question 26. A network security engineer needs to implement a firewall solution that can perform stateful packet inspection at layer 4 while also providing advanced filtering capabilities at layer 7. Which type of firewall should they deploy? That's going to be a next generation, right? That's going to be a next generation firewall that can do both, can do that deep packet inspection by doing TLS, decryption. Question 27. Which of the following best describes a key benefit of implementing SASE, Secure Access Service Edge, for an enterprise? So, right, that's going to centralize a lot of things for us. That's going to allow us to do SD-WAN and then, zero trust network architecture. It's going to allow us to do secure web gateways. It's going to allow us to monitor and apply policy to our cloud resources using like CAS-B. So, which of the following best describes a key benefit of SASE? I'm going to go with A here. SASE integrates networking security into a cloud-based framework for distributed access. Remember, SASE is not a physical device, right? It's going to be virtualized. It's going to be in the cloud or, at the edge, but virtualized. Pause the video if you'd like to read the explanation. Question 28. Which of the following data classifications is most appropriate for trade secrets, trade secrets that provide a company with a competitive advantage? So we want to put a data classification on trade secrets. So we're going to go with confidential. It's not critical because if it gets exposed, it's not going to bring down our operations. It's not public, obviously. And restricted kind of deals more with like regulations. This is kind of just like capitalism type stuff, trade secrets, giving us a competitive edge. So we're going to go with C, confidential. Pause the video if you'd like to read the explanation. Question 29. Which of the following best describes the difference between load balancing and clustering in high availability architectures? Remember, load balancing is on the network and clustering is more of like our compute resources, pulling resources together. So I'm going to go with C here. Load balancing distributes traffic across multiple servers, while clustering allows multiple servers to work as a single system for failover and redundancy. Yeah, failover really just like to increase our scalability, right? Pause the video if you'd like to read the explanation. Question 30. Which of the following best describes the primary function of a web application firewall? So a web application firewall just deals with HTTP. That's its whole purpose, to protect us from web application-based attacks. So I'm going to go with A. It inspects and filters HTTP, HTTPS traffic to protect web applications from attacks like SQL injection and cross-site scripting, just web-based attacks, right? That's its actual function. Pause the video if you'd like to read the explanation. Question 31. Which of the following best differentiates a next-generation firewall from a traditional firewall? Remember, a next generation, that does our URL, our content filtering, deep packet inspection. It can do a lot of things. It can do user behavior baselines. It can monitor. It can do IDS, IPS. So with traditional, it's just layer 3, layer 4, stateful, stateless filtering. That's it, right? So I'm going to go with C here. So a next generation firewall integrates intrusion prevention, application control, and deep packet inspection, while a traditional firewall primarily performs stateful packet filtering. It is stateless too, but yes, that is the answer. So pause the video if you'd like to read the explanation. Question 32. An organization classifies customer billing records as private data. What is the primary reason for this classification? So billing records, that's PII, right? So that's why it's private. It's personal to that user. Pause the video if you'd like to read the explanation. Question 33. A security administrator needs to ensure that remote administrators can securely access internal systems while minimizing exposure to threats. Which of the following is the best solution? It's going to be some sort of proxy or jump server right away, right? Because we're talking about remote administration to internal systems that we want some sort of extra protection, so we're not going there right away. So I'm going to go with A. Use a jump server to provide controlled access to internal systems. Pause the video if you'd like to read the explanation. Question 34. Which of the following best differentiates sensitive data from public data? So sensitive data already, right, is it's kind of easy in the term. Sensitive data is something you need to protect. It's something that if it gets breached, it's going to do damage, right? That's critical. But sensitive data could be your IP, could be your trade secrets, could be anything that you don't want exposed to the public or to the internet. Where public data is, that's why it's called public. So sensitive, I'm going to go with D. Sensitive data is protected and access controlled, while public data is freely accessible. Pause the video if you'd like to read the explanation. Question 35. Which of the following security concerns is most relevant when using a hybrid cloud model? So a hybrid cloud model, that could you could use the public and private cloud in combination in your organizations. You can do on-prem stuff with your public cloud, right? So we're going to go with A here, ensuring compliance with internal data sovereignty laws. The only thing that makes sense, right? It doesn't eliminate the need for security controls. You still have the dependency of an on-premise hypervisor because hybrid does involve on-prem sometimes if that's your hybrid, environment. So we're going to go with A here. Pause the video if you'd like to read the explanation. Question 36. Which of the following best describes the primary security risk associated with risk transference in cloud computing? So risk transference is offloading your cybersecurity risk to a third party, like insurance, really, any third party, right? So with cloud computing, that doesn't really change. It's still what it does. It just offloads the risk. So we're going to go with C. Security compliance depends on the cloud provider's policies and implementations. And that is true, right? Because we have that responsibility matrix. So risk transference involves shifting certain risks to a third party in this case being that CSP. Sometimes you see this, it's really trying to get you to like risk transfers, cybersecurity insurance, but that's okay. Moving on. CSP, a cloud service provider, is technically still a third party. Okay, question 37. An organization labels its financial transaction records as critical data, meaning it can cause severe damage, right, if it gets exposed. What does this classification indicate about the data's security needs? So critical data. So it's something we need for our operations. It has to be kept confidential, but we need availability to it, right? It's not complete. I mean, if someone needs access to data, does not see stored in an offline system. No, I think the best answer here is B. It must be readily available, and downtime or loss could cause severe operational impact. Yes, it went for the availability kind of concern here, but it's also like it can't be exposed, right? So, but we're gonna go with B here. It must be readily available, and downtime or loss could cause severe operational impact. Question 38. A multinational corporation needs to ensure compliance with data sovereignty laws when storing customer data. Which of the following is the best security control to enforce compliance? So obviously it's international. I mean, it matters where we are, right? So I'm going to go with D here. Geolocation-based restrictions that prevent data storage outside specific countries. We're international, so we need to know where we are when applying security controls. Question 39. Which of the following best describes the security risks associated with a fail open mode in an enterprise environment? So that fail open, right? That's where everything else fails. And instead of shutting down a system or whatever the case may be, we're still operational. So we're gonna go with C here. Security mechanisms may be bypassed, allowing unauthorized access during a failure. Pause the video if you'd like to read the explanation. All right, last question here. We're gonna go 100% here. So let's do our last question. And remember, this is all available for purchase at our website, this learning management system. So question 40. A company is conducting capacity planning to ensure its security team can effectively respond to incidents. Which of the following considerations best addresses the people aspect of capacity planning? So this is what I'm thinking it's saying is like, do we have enough engineers on staff, on call to make sure our capacity planning can work, right? So we're gonna go with C, ensuring adequate staffing levels and training for security personnel to handle incidents. Pause the video if you'd like to read the explanation. All right, let's go. We got 100%. I want to thank you all for viewing. Make sure you like, subscribe, share with your friends, and I'll see you in the next video where we go over domain 4 questions.